Hello my dear students, my name is Ankit Dongriyal and I am your mentor from Civil Engineering Department. I welcome you all on this YouTube platform of IMS GATE Academy. Dear students, as you already know, this is the very high time when we should boost our preparations to the next levels, and in this particular series, and to help you in this particular series, I am here with the session of geotechnical engineering. You might be having the idea of the importance of this subject, as the weightage of this subject is highest in your civil engineering, right? It is almost having a weightage of from 12 to 15 marks and sometimes more than that, right? So from your exam point of view, this particular session, it is going to be very important. Other than that, this is the particular time when students feel demotivated, right? This is the particular high time when a student can boost his or her score, or a student get demotivated by giving the test series, by having the so much syllabus to revise. Sometimes this particular thing happens. So whenever you feel demotivated, ask yourself one question, that why you have started this particular journey of GATE exam, right? As this particular GATE exam, it is not like that someone has forced you, your parents had forced you to give this particular exam. It was you who has decided to give this particular exam so that you can do good in your career, so that you can do very good in your life, right? Yeah, hello Rakesh Verma. I am good. I hope you all are also doing very great. Hello Nikhil sir. Hello Shashikant. Yeah. So in this particular series, I am here with geotechnical engineering. As we already know that geotechnical engineering has very much important in our civil engineering and in our particular GATE exam also, right? So if we talk about, we are going to start from the basics and we are going to cover all the important concepts, all the important questions from this particular subject, right? By then, just share this particular session and like the session so that all other students also get benefited by this particular session, right? So what we are going to discuss first, we are going to discuss about the index properties of soil. We are going to see that the three-phase system of soil and the classification of soil. This is the first part of our particular session. In this particular session, we are going to cover almost half of our particular syllabus. There will be a next session tomorrow also at the same time, and in that particular part, we will try to cover our complete syllabus, right? So we will start with the three-phase system of soil. We already know that soil consists of your solids, water and air. That's why we call it as a three-phase system, right? Now, if I am saying that it is consist of solid, water and air, it means these constituents of soil, they are going to influence the properties of soil. They are going to influence the properties of soil, right? Why we want to study the properties of soil? As we know that our superstructure, it is going to get constructed over our soil. If due to that particular construction, the properties of soil will get changed, it is going to affect our superstructure also, right? That superstructure, it can be your any building, it can be dam, even it can be any particular highway, right? So for that particular thing, this study of geotechnical engineering is very important, right? So these are the common terminology which I am going to use. So this VS, it denotes your volume of solids. So I'll just write what are the terminology I am going to use for this particular course. VS is your volume of solid, right? Volume of solid. I'll be little fast so that we'll be able to cover this particular subject, right? This VV, that is your volume of voids. That is your volume of voids, right? We know that the soil consists of solids and soil consists of these voids. Now these voids, they get filled with water or either air or both, right? Now this VW, I am going to use it for the volume of water, this volume of water, and I will use VA for the volume of air, for the volume of air. Capital V, it will be our total volume of soil. it will be our total volume of soil. It will be our total volume of soil. Clear? As these constituents are going to influence our particular properties of soil, so we should know that how much solids are there, how much water is there, how much air is there in our particular soil. Right? Now, these are the particular parameters in terms of volume. Right? So this volume of solid, it will give you the particular quantity, how much solids are there, how much voids are there, how much your water or air is there. Right? Also, we can do this particular thing in terms of weights. Right? So also we have this WS as weight of solids. Right? WW is your weight of air and total W is your W, capital W is your total weight of soil. This weight of air, generally we neglect the weight of air. Volume, weight of voids, this is not any particular quantity. Right? Now, to define particular how much amount of water, how much amount of air is present in your soil, we have different parameters for that. Right? So we have some volumetric parameters, we have some weight parameters. Before that, in some particular conditions, your soil can also be two-phase system. In particular cases, your soil can also be a two-phase system. In which particular case? Let's suppose if your particular soil is dry, it means all the voids of soil, they are completely filled with air. There is no water in soil. If you will just dry your particular soil, in that particular case, in the voids of soil, there will be only air. This particular type of soil, it will be your dry soil. So you can see here, it is only two-phase system. There is only solids and there is only air. Right? There is another case, that is of the saturated soils. There is another case of saturated soil. In this saturated soil, if all the voids of soil are filled with water, if all the voids of soil are filled with water, what you can say that it is a two-phase system. This particular case, it will be your saturated soil. Right? So when your complete voids are filled with air, it will be your dry soil. If all the voids are filled with water, it will be your saturated soil. Clear this thing? Next thing, now to define that how much water is present in our soil, so it can be done either in terms of volume. Right? So we have some dimensionless quantity such as your void ratio. So what this void ratio represent? It represents that how much volume of voids are present with respect to volume of solids. So it is particularly the ratio of your volume of voids to the volume of solids. Clear? We generally represent in terms of volume of solids, as this particular volume of solid is more stable quantity as compared to total volume. But as it is difficult to directly calculate this volume of solids, so what we do? We define one another term, that is porosity. We have defined another term, that is porosity. So what is this porosity? It also tells you about the volume of voids, but in terms of total volume of soil. So what is this porosity? This porosity is your volume of voids to the total volume of sample. Clear? Also, in those voids, how much water is present? In those voids, how much water is present? For that, we have another quantity, that is degree of saturation. That is degree of saturation. Yeah, good evening, Saurabh. Right? Okay. Thank you, Saurabh. So here you can see degree of saturation. What this degree of saturation tells us? This degree of saturation, it is the volume of water. It is the volume of water with respect to your volume of voids. It means how much water is present in terms of volume in your voids. Right? Now try to see. Now try to see. Yeah. Yeah, good evening. Good evening, good evening. Right? Now try to see. If in your voids completely air is there, it means volume of water will be 0. If all the voids are filled with air, it means your volume of water is 0. So in that particular case, what will be this particular value? Degree of saturation will be 0 and your soil will be dry soil. Right? This is what we have seen. Another thing is, if all the voids are filled with water, in that particular case, your volume of voids and volume of water are going to remain same. These particular values will be same. So what will be this particular ratio? It is going to be 100%. Right? It is going to be 100%. So if your degree of saturation is 100%, you will say it is a saturated soil. If your degree of saturation is 0, you will say it is a dry soil. I hope This particular concept is clear. So what are these particular terms? They are just telling us that how much water or how much voids are there in a particular soil, right? Now, if we talk about, there are other terms also, like your air content, right? Like the air content, how much air is present in your voids, that particular thing, it can be represented by your air content, right? You represent it by A suffix C. So what will be this air content? Air content, it is nothing but your volume of air in your volume of voids. Volume of air in your volume of voids. Yeah. Okay. Another thing is your percentage air content. Another thing is your percentage air content. Clear? Generally we represent it with nita percentage. So what this particular value says, this is nothing but it also tells about what is the volume of air, what is the volume of air with respect to total volume of soil, with respect to total volume of soil, right? Now, one important relation, if you see, if I add degree of saturation with air content, so what I am going to get? Degree of saturation, I know it is volume of water upon volume of voids plus air content is your volume of air upon volume of voids. I know in voids either it can be air, either it can be water, or it can be both, right? So can I say that this particular value, it will be what? Volume of water plus volume of air. It will also be volume of voids by volume of voids. So this particular value is equal to 1. Important parameter, that is S plus AC, it is equal to 1. Right? Also you can remember one particular result for this percentage air content, that neta is equal to your porosity into air content. Porosity into air content. These are some important results, right? Now there can be the representation in terms of weight. So there is one weight ratio, that is your water content. So what this water content suggests? It says that how much water is present with respect to the weight of solids, or you can say how much weight of water is there with respect to weight of solids. Why we are measuring in terms of weight of solids? As the solids are more stable quantity as compared to total weight, right? If we talk about, we know that the total weight of soil, it consists of weight of solids and weight of water, and this weight of water, it's going to change if you will change the water content, right? If the amount of water, it will get changed, right? So this particular weight of total weight of soil, it is going to change. Also total volume of soil, it is also a frequently changed quantity. So it is better to represent in terms of solids, right? Sometimes nowadays a particular new quantity is also used, that is your volumetric water content. That also you can remember, that is your volumetric water content, right? So nowadays mainly if you will see the new research, so in IITs if you will see the new research, this water content we generally also represent in terms of volumes also, right? So that is your volumetric water content. Generally we represent it with theta. So what is this volumetric water content? It is your volume of water with respect to total volume of soil. Always remember, it is with respect to total volume of soil. Why total volume of soil? As we know that volume of solids, it is difficult to obtain, right? Whereas this weight of solids, you can easily obtain it. If you will dry your soil, your water will get eliminated. The the weight of air, we generally eliminate that particular value also. So we can say that, okay, if we are having a dry soil, in that dry soil, the weight will be is equal to weight of solids. So it is easy to obtain. Whereas if you will dry a particular soil, that soil will not have volume equal to volume of solids, as even after drying there will be some volume which will be taken by air, right? So it is better to represent in terms of total volume. So this is your volumetric water content. It also gives you how much water is present in total volume with respect to in terms of volume, right? Okay, I hope up to this particular point there is no doubt. Just let me know in the comment box. Just let me know in the comment box how many students are here. so that I can just see the names. Okay, from different centers. If you are attending the class, just give your presence in the comment box. Yeah, okay, Rakesh, right? So next thing is here, if we talk about the relation between your weight and volume, if we talk about the relation between your weight and volume, right? Whenever you are comparing two objects, when you are comparing the weights of two things, yes, I can remember, Rakesh, right, from the online classes, right? If you are comparing two particular quantities in terms of their weight, you can only compare if their volume is also same, right? So for that particular quantity, we use this gamma value, right? That is unit weight or sometimes density. So what is this density? Density we know. Density is your mass by volume, right? What is the mass of any particular quantity with respect to its volume? Clear? Similarly, we have gamma value, that is weight by volume. It is nothing but the ratio of weight by volume, right? So in particular soil, if your soil is dry, what will be this particular value? It is going to be the dry weight of soil upon total volume of soil. Remember, it is dry weight of soil upon total volume of soil, right? I know that the dry weight of soil, it is equal to weight of solids. Remember this particular thing. It is going to get help in many of the questions. Remember, the dry weight of soil is equal to your weight of solids. But your volume of dry soil, it is not going to equal to volume of solids. It will be equal to, if we talk about total weight, it is equal to weight of solids plus weight of water, and total volume, it is equal to volume of solids plus volume of water plus volume of air. If I am saying this is a dry soil, it means this particular value is 0, this particular value is 0, right? So total weight of soil, it is equal to weight of solids, but total volume of soil, it is equal to weight of solids plus weight of air. Remember this thing, right? This is the particular point where students make mistake. So what they do, they sometimes take this gamma d as weight of solids upon volume of solids. No, that is not the dry weight, that is the unit weight of solids. Clear? Second thing is your total, or sometimes you call it as wet, sometimes you call it as a bulk unit weight or moist unit weight, or you can say just it is a unit weight in the natural condition, right? Whatever is the water content or degree of saturation, your degree of saturation, if it is 0, it will be your dry soil. If it is equal to 1, it will be a saturated soil. But in the most of the cases, it can be in between 0 to 1. So you will call it as a partially saturated soil. So for that, we are having this particular quantity, that is your gamma bulk. We generally represent it with gamma suffix b. That is your weight of soil upon volume of soil. That is your weight of soil upon volume of soil, right? What will be your weight of soil? That is the weight of solids plus weight of water. What will be total volume of soil? That is weight of solids plus volume of solids plus volume of water plus volume of air, right? Now, if the degree of saturation is equal to 1, if all the voids are filled with water, in that particular case, you will get the saturated unit weight. You will get the saturated unit weight. In that particular case, what will be this particular value? It will be total weight of soil upon total volume of soil, right? What will be the difference in between these two? In these two, if we talk about here volume, so when you are writing gamma bulk, your volume will be volume of solids plus volume of air plus volume of water. As in your soil, there is solids, air and water. But if you are talking about the saturated unit weight, the weights are same. The numerator is same. But if you talk about this denominator, this particular value will be what? This will be your volume of solids plus volume of water only. As there is no air. When all voids are filled with water, it means there is no air. Clear? Now we know that this particular gamma value, it is not unitless. It is having a unit. Generally in soil, we will represent it in the terms of kilonewton per meter cube, right? It is weight by volume. So it will be kilonewton per meter cube. So we know this is not particularly a unitless quantity. Now, if we want to represent the gamma of your soil in terms of unitless quantity, so for that, we have another parameter, that is your specific gravity. So what is this specific gravity? This specific gravity, it is the ratio of gamma of solids with respect to, or unit weight of solids with respect to unit weight of standard fluid. What is that standard fluid? That standard fluid is your water at 4 degrees Celsius. That is your water at 4 degrees Celsius, right? And this particular gamma W, at this particular value, it will be is equal to your 9.81. Remember the units, it will be kilonewton per meter cube. Clear? If we are talking about the densities, we can also write it as like this: density of solids upon density of water. So what is your density of water? Density of water is your 1000 kg per meter cube. Clear? Sometimes we represent in terms of gram per cc. So it will be 1 gram per centimeter cube, right? So these are the important values which should be known to you. Clear? Now, so your GS value is nothing but it is the unit weight of solids to the unit weight of water. What is the unit weight of water we are going to consider? That is for the standard fluid, that is at 4 degrees Celsius. As at this particular temperature, your gamma value will be, or your density of water, it is going to be maximum, right? Now these are the some most important relations. You will get definitely one question with respect to these formulas, right? We call it as brain of soil mechanics. These are that much important as of for you, your brain is, right? So brain of soil mechanics. Brain of soil mechanics. Clear? So remember these formulas. What is this? Your degree of saturation plus air content, it will be is equal to 1, right? If these formulas are not known to you, you should remember all these formulas, right? I am not going to drive all these formulas, as we are more concerned about the questions and difficult concepts which I am going to discuss in this particular session. But I am just giving you one quick idea that what we have learned in the classes and what we need to implement in this particular session, right? Your NITI, that is percentage air content, it will be N into AC, that is N is your porosity, AC is your air content, right? Most important relation which generally used in all questions, that will be S into E is equal to W into G. This S is your degree of saturation, E is your void ratio, W is your water content, and G is your specific gravity, right? Also, we have a relation between porosity and void ratio, that porosity N is equal to E upon 1 plus E, and we know that E is equal to N upon 1 minus N. E is equal to N upon 1 minus N. We also know that your weight of solids, it is nothing but total weight upon 1 plus water content. Weight of solids is equal to total weight upon 1 plus water content. You can just remember it like that. You want weight of solids. You are having total weight. Out of that total weight, what you have done? You have just removed this water content, or you have just removed this water, right? So it will be total weight upon 1 plus W. It is just to remember. Also, volume of solids. You are having total volume. Out of that total volume, if you will remove the volume of voids, who represents the volume of voids? This E value. So you have just dragged this 1 plus E. So you got this as a volume of solids. I hope these particular relations are known to you. Also, some of the most important relation, that is for the unit weight, right? As this unit weight, they will help you to find out the weight of your soil, the stresses in particular soil, right? So in the later chapters, these particular formulas, they are definitely are going to use, so it should be known to you, right? Okay. You can find that, right? Try to find that, you will definitely get that. Try to find out that. Okay. So this is the gamma, that is your bulk unit weight of soil. This bulk unit weight, it is G plus SE upon 1 plus E into gamma W. Clear? Now, this particular value, this is your bulk unit weight. Now, I know that this is for the natural condition. This is for the natural condition. If in the natural condition, my degree of saturation is equal to 0, can I say it is a dry case? Can I say it is a dry case? So what will be your gamma value? If you take S is equal to 0, it will give you the gamma dry value, that is G gamma W upon 1 plus E. Similarly, if your degree of saturation is equal to 1, it is going to be your saturated soil. It is going to be your saturated soil, right? So your gamma saturated will be G plus E upon into gamma W upon 1 plus E. Clear? Now, if your particular soil, it is below the water table, if your soil is below water table, let's suppose this is your water table and this is the ground level, right? If we talk about what this gamma represents mainly your weight of soil with respect to volume, right? Or per unit volume. So your weight of soil, it will be in downward direction. There will be one force of buoyancy in upward direction, right? So the apparent weight of soil, it is going to get decrease. So if you are taking that apparent weight into consideration, so you will get this particular submerged value, that is your gamma submerged. So whenever your particular soil lies below water table, that soil you consider as your submerged soil. It is also saturated, as all the voids are filled with water. So it is saturated but also submerged. Clear this thing? Yeah. Hello RK Gautam. Right. So if we talk about the submerged unit weight, it is G minus 1 upon 1 plus E into gamma W, right? Or you can also write it as in terms of porosity, that is G minus 1 into 1 minus N into gamma W. Clear? Or also you can say gamma submerged is nothing but gamma dry plus 1 minus N into gamma W. Clear? So these are the different formulas. This particular formula, gamma D is equal to G into 1 minus neta A 1 plus WG. This is also one important formula which generally used in your compaction chapter, right? So what is this neta A? In terms of neta A, that is percentage air content. You also have this dry unit weight of soil. Clear? Also one important relation, that your gamma dry value is also equal to your gamma bulk upon 1 plus water content. Gamma bulk upon 1 plus water content. Clear? So if you are going to give the GATE 2023, this particular formula, it must be in your tips, right? Now try to say this particular note. This particular note, it is going to get help you in many of the questions. So whenever there is a question with related to mixing of soil, excavation of soil or transportation of soil, you generally get a question like this, right? On the mixing of soil or excavation of soil, you have excavated some soil from one place to do the construction at second place. Let's suppose for the highway, you want to make one embankment for highway. So it is not necessary that wherever you want to make that embankment, at that particular place soil is present. So you have to take the soil or you have to transport the soil from other places. Those type of questions are also asked. So in those type of questions, there will be two situations. One for embankment, second will be for the borrow pit, right? So whenever there will be two conditions, you have to compare those situations. So remember my friends, whenever there are two situations, remember this particular thing for every subject. Whenever there are two conditions, you have to see that in those two conditions, which particular quantity is constant. Which particular quantity is constant. Then only you can compare those particular conditions, right? So whenever there is a question from mixing, excavation or transportation of soil, remember that your weight of solids and volume of solids, they are not going to get changed, right? It means what? If you are mixing two soil having a volume of solid 1 and mixing another soil with volume of solid 2, so when you will mix these solids, your volume of solids in the mix will be nothing but the summation of these two. Same is the criteria for your weight of the solids. It means it is not necessary if you are mixing soil 1 having a volume V1 and second soil having a volume of V2, it is not necessary that if you will mix those soil, you will get the total volume as V1 plus V2. It is not true for your total volume of soil. It is not true for your total volume of soil. As you know, there can be change in the void ratio, right? Similarly, in terms of weight, there can be change in water content when you are transporting the soil or when you are mixing the soil. Clear? So this is one important concept which should be known to you whenever you have to compare, when you have to deal with some of the questions from the mixing, excavation or transportation of soil. Remember these things, that the weight of solids and volume of solids, they are going to remain constant. Up to this particular, if there is any doubt, you can ask, or otherwise we can move further, right? Just let me know in the comment box if you are having any doubt. Yes, Rakesh. Yes. Is it fine? Should we move? Okay. Next thing is our index properties. Next is our index properties. So what is this index properties? For the classification and identification of soil, the properties which are used, those we are called as index properties of soil. Clear? So we generally classify soil as gravel, sand, silt and clay based on their particle size, right? So generally up to this particular point we call it as a soil up to 80 mm. Up to 80 mm. So from 80 mm to 4.75 mm, I will say that particular soil is gravel, right? If the particle size is in between 4.75 to 75 micron, it will be your sand. From 75 micron to 2 micron, it is going to be your silt, and less than 2 micron, it will be your clay. Now, these two soil, silt and clay, this silt and clay, it means this 75 micron, it is the deciding size for your fine grained soil and coarse grained soil, right? These sand and gravel, they are in the category of coarse grained soil, whereas this silt and clay, they are in the category of your fine grained soil. Clear this particular thing? Also, if we talk about this 4.75, right? If I talk about this 4.75 mm, so this 4.75 mm, it is the deciding criteria or deciding size for your gravel and sand. Clear? So one of the index property, that is our particle size distribution. What we do in particle size distribution, we want to find out that what is the distribution of different size of particles in our soil, right? So why we want to do that? As we know, if any particular soil, it is having the particles of different sizes and different range of sizes, it will get more compacted, it will have high strength, right? Or we generally call it as a well graded soil. If any particular soil having the grading of particle size, it is having the particles of gravel, sand, silt and clay, so it will be a particular well graded soil, right? So by this distribution curve, we can find out that any particular soil is well graded or not. Also, the main important thing for us is the analytical method, right? Based on the formulas also we can say if any particular soil, it is well graded or poorly graded. For that particular thing, we use two parameters. What are those two parameters? One of the parameter is your coefficient of uniformity, that is nothing but the ratio of your D60 by D10. Another quantity is your CC value, that is your coefficient of curvature, that is nothing but the ratio of D30 square upon D60 into D10. Sir, what is this D60? This D60 is that size of sieve below which 60% of particles are finer, right? Okay, I am you. Thank you for the compliment, right? Okay, this CU is nothing but it is D60 by D10. What is this D60? It is that sieve size below which 60% of particles are finer. What is this D10? This is that sieve size below which 10% particles are finer. Clear? This similarly D30, it means this is that particular diameter of sieve below which 30% particles are finer. I hope it is clear to you, right? This D10, sometimes we also call it as a effective size given by your Allen-Hazen, right? So whenever you will see the equations of Allen-Hazen, you will find out this particular quantity also, right? D10. Now, how to find out this D60, D30, D10? That we are not going to cover in this particular session, but on the basis of your this particular chart which you construct in terms of percentage finer and particle size, from that you can get this particular value, right? So it means if we talk about this, this is your D60 value. This is your D60 value, right? Similarly, if we talk about D30 or D10, it will be somewhere here. This particle size, this is your D60, this is your D10. Clear? Generally, we make a particular chart for that in terms of percentage finer and diameter of the particle. From there, we can find out. That what is your D60 and D10. Now, these particular parameters are used to classify soil as well graded or poorly graded. How to classify any particular soil if it is well graded or poorly graded? Right. So we generally use this parameters for your coarse grained soil. So in gravels, if your CC value in the range of 1 and 3, if your CC value is in between 1 and 3 and your coefficient of uniformity is greater than 4, you will say, okay, that particular soil is your well graded soil. Whereas in case of sand, if CC value is in the range of 1 to 3, right, and your CU value is greater than 6, you will call it as a well graded sand. Otherwise it will be your poorly graded sand. Clear that thing, right? So these are the parameters for which you can classify your soil. Next thing is your consistency of soil. So what this consistency of soil represents? Consistency of soil, it is the ease with which you can modify the soil, right? With increase in water content, your firmness of soil, it is going to change from solid, then semi-solid, then plastic, and finally to liquid, right? So this particular change in firmness, it is represented by the consistency of soil. Mainly it represents that how your soil going to behave with change in water content. For that, I have just prepared one chart with respect to water content and volume, right? So when you are increasing the water content, your soil, it is first solid when the water content is almost 0. When you keep on increasing the water content, initially your volume was dry volume. So try to see here. I will just represent it with the three-phase system also so that it will be clear to you. Right, this is our soil. Initially it is in the dry case, right? It means these are the solids. And this particular is your voids. If I am saying the soil is dry, it means initially these voids are filled with air only. So your soil will be having this particular volume. At this particular point, your volume of soil is this. Now you are keep on increasing the water content. If you will keep on increasing the water content, that air, it will take the space here in the voids. Will there be any change in volume of soil? No. This is your volume of soil, right? There is no change in the volume of soil up to this particular point. You have keep on increasing the water content. There will be a particular water content at which your soil will be just saturated. There will be one particular water content at which your soil will be just saturated. Clear? So that particular water content, it is nothing but your shrinkage limit. It is your shrinkage limit, right? You can also say that this shrinkage limit, it is the boundary water content for solids and semi-solid state of consistency. Clear? Also, from the determination of point of view, we can say that this is the particular water content at which your soil is just saturated. After that, if you'll keep on increasing the water content, your volume of soil, it is going to increase. Your volume of soil, it is going to increase. So initially this was the volume. Now there is a change in volume, right? Now there is a change in volume. As the volume of water now increases, in the same amount, your volume of soil also going to get increase. Clear? So there will be one particular water content which will separate out this semi-solid and plastic state. This we call it as a plastic limit. This we called it as a plastic limit. Also, that particular water content at which there will be a phase change from plastic to liquid. From plastic to liquid, this particular water content, we call it as a liquid limit. I hope it is clear. Now, if we talk about from the determination point of view, this liquid limit, you find out it with the help of Casagrande tool, right? Or Casagrande apparatus, you will find out this liquid limit. What is this liquid limit? From determination point of view, this is the particular water content at which in 25 number of blows, a groove which is made with the standard tool, it will get filled, right? So you might have seen this particular type of instrument, right? So you will make it fall from the 1 centimeter height, and if in the 25 number of blows, the groove which you have made in this particular soil with a standard tool, that will get filled up in 25 number of blows. So that corresponding water content will be your liquid limit. Clear? What is this plastic limit? Plastic limit, mainly you do that particular test, you make a 3 mm thread, right? So that particular water content at which, while making the thread of 3 mm, at which the cracks will get evolve, or that particular soil, if it start getting crumble, that will be your plastic limit, right? shrinkage limit, mainly we find out it in the terms of that this is the particular water content at which soil is just saturated. Also important point related to this shrinkage limit is, if you are decreasing the water content, this is that particular water content below which if you will decrease your water content, your volume of soil, it is not going to change. It means your volume of soil is not changing, your volume of voids are not changing. If volume of void is not changing, volume is not changing, we know that volume of solids are constant. It means your void ratio and porosity is also constant. Clear? So below this water content, your porosity, your void ratio, your total volume of soil, all these things are constant. Yeah, thank you, Himanshu. Right. Now, based on that, we are having different indexes that you can remember the formulas for that, like flow index we have, right? That particular, if we draw the chart, that flow curve for the determination of water content, the slope of that particular curve, we call it as a flow index, right? We are having that liquidity index, consistency index, also we have toughness index, plasticity index, right? So you can remember the formulas for all these things. We also having activity, right? We are having sensitivity, that is nothing but the ratio of your unconfined compressive strength for your undisturbed soil to unconfined compressive strength of your remolded soil. Clear? Activity we have IP upon activity is also your IP, that is your plasticity index upon percentage of clay content, right? So all these are the formulas which should be known to you. After that, if we talk about the classification, right? So in classification, one of the important classification is for your coarse grained soil, that is mainly done in terms of, first criteria is your particle size distribution. It means based on Cu and Cc value, you will classify if it is a well graded soil or poorly graded soil. This particular classification we generally do when the percentage of fine grained soil in your soil, they are less than 5%. If this particular value it is greater than 12%, you have to classify those fines also, right? And that particular thing either you can do on the basis of this plasticity chart, or also we remember that if your IP value it is less than 4, so you set it to be silt, and if your IP value, that is plasticity index value, if it is greater than 7, you call it as clay, right? What is this IP? This IP is your plasticity index, nothing but liquid limit minus plastic limit. I hope all these things are known to you, right? As we are just going through the revision part, right? Now, if I talk about the fine grained soil, the classification of fine grained soil, it can be done based on your plasticity chart. So you should remember this particular chart. There are the few things which you should remember, that first is your A line. First is A line, right? So this particular plasticity chart, it is nothing but here in x-axis you are having liquid limit and here you are having the plasticity index. Now this A line separate out your clay and silt. What is the equation of this A line? It is 0.73, or you can say IP is equal to 0.73 WL minus 20. This is the equation of this line. Also, this is the IP, I'll call it as a IP of A line. I'll just call it as IP of A line. Clear? You can also find out IP of soil, that is plasticity index of soil, that is nothing but liquid limit minus plastic limit. You know IP of A line, you know IP of soil. It means you can say, you can classify if this particular soil, it will lie above A line or below A line based on these two values, right? If your particular soil value or IP of soil, it lies above A line, so this is going to be your clay. Above A line, it will be clay represented by C, right? Whereas below A line, it is going to be your silt represented by M. Remember these things. Silt is not represented by S. S symbol, it is reserved for your sand. Clear this thing? Now, also based on the compressibility, we also classify fine grained soil. So try to remember these values, right? If your water content, once you have just separate out that if it is clay or if it is silt based on the value of IP of A line, IP of soil. Now try to see what is the liquid limit of your soil. Now try to see what is the liquid limit of your soil. If the liquid limit of soil, it is less than 35%, if the liquid limit of your soil, it is less than 35%, it will have a low plasticity. Clear? Whereas if liquid limit value, it lies in between 35 to 50%, it is going to be your intermediate plasticity. And if liquid limit is greater than 50%, only these three values you need to remember. If your liquid limit value is greater than 50%, if your liquid limit value is greater than 50%, it will be your high plastic soil, right? So here you can see that this CH, it is nothing but your clay with high compressibility. This clay with high compressibility, right? Similarly, in between 35 and 50, it will be your clay with intermediate compressibility, CI. And below this, it will be CL, that is clay with low compressibility. Similarly, you can say for silt also, that it will be your MH in this particular range, it will be your MI in this particular range, that is silt with intermediate compressibility, and in this particular case it will be ML, right? This particular A line also separate out what is liquid limit. Liquid limit, okay, this liquid limit is that particular water content, right, from which the phase of your soil, it is changing from either plastic to liquid, or you can say from liquid to plastic. Clear? So this is the particular value of that water content at this particular phase. Okay, now based on this IP line, you can also classify your soil if it is organic or inorganic. Below this particular A line, your soil is going to be organic. I hope it is clear, right? So these are the particular part from your classification of soil. So we have already covered your three-phase system of soil. We have covered the consistency of soil or index properties of soil and classification of soil, right? Now this is the particular question which you need to solve. Just go through this particular question and try to solve this. Just read the question and try to solve this particular question. Read the question and try to find out what question says. Right, I'll just read the question for you. It is given that a moist soil sample weighs 346 gram after drying at 105 degrees Celsius. As we know, this particular temperature we use in oven drying, right? It means this particular weight, it is your weight of dry weight of soil, right? So your weight reduced to 284 gram if the specific gravity of soil mass, is given, right? It means GM value is given to you, and we know that it is nothing but your gamma of soil upon gamma of standard fluid, right? Specific gravity of soil mass and of solids is given to you. So GM value is given to you, that is 1.86, and G of solids is also given to you. This is your G of solids, this is your GM. The degree of saturation of soil is, and it is asking for the degree of saturation, that is S value. Clear? So this is the particular data given to you and you need to find out. Okay, there is one answer, that is 76.8. Okay, other students, you should also try. We'll just see if this particular answer is correct or not. Just give a minute to this particular question and try to solve this, right? After that, I'll also explain you that what is the correct answer. By then, just try this particular question. As these questions are for your practice, right? I want each and every question to be solved by you guys. Okay. Just give this particular question a minute and try to give me the answer. And try to give me the answer. Okay. Now try to see, we need to find out how we can proceed? What we need to find out, that is your degree of saturation. That is your degree of saturation. We know that for degree of saturation we need the volume of voids, the volume of water upon volume of voids, right? Volume of voids. That is your degree of saturation. We need in percentage, so multiply by 100. Himanshu is saying C 52.5. Okay, so we are getting B 76.8 and 52.5. Any other answers? Any other answers? Okay, just we'll see what is the data given to us. What is the data given to us? GM value is given to me. What is GM value? GM value is 1.86, GS value is 2.7. 1.86 and specific reactivity of solids is given to as 2.7. Clear? Any other values given? Sample moist soil weight is given to you. It means weight of soil, and this is your dry weight of soil. Weight of soil is given to you as 346 gram, right? And weight of solids is also given to you. This particular value is here 284 gram, right? This particular value is here 284 gram. Now Rakesh 52.5. Okay, let's just see. Now I know that this GM is nothing but gamma of soil upon gamma of water, right? Or I can say that is rho of soil, density of soil upon density of water. That is our mass of soil upon volume of soil upon density of water. As we are dealing with gram, right? I can say this, it is your 1 gram per cc. 1 gram per cc. So can I say that volume of soil, it is equal to mass of soil upon GM value. Mass of soil upon GM value. Similarly, what we can say from this, I can say that volume of solids, it will be equal to mass of solids upon GS value. Mass of solids upon GS value. Clear? Now, mass of solids upon GS value. So from here, can I get this? Can I get this volume of soil? Total mass is given to you 346 upon GM value is given to you 1.86, right? And from here I can say that this volume of solids, it will be your mass of solids. Mass of solids is what? Your mass of solids is this particular value, right? 284. 284 upon G of solids is your 2.7. So it will give you volume of solids. It will give you volume of solids, right? Now, can I say that? Okay. Can I say that your void ratio E value, your void ratio, we know that it is volume of voids upon volume of solids. Volume of voids I can write total volume of soil minus volume of solids upon volume of solids, right? From here if I calculate this E value, what will be this E value? This is your volume of this is your total volume of soil This is your total volume of soil. This is your volume of solids. This is your volume of solids. Can you give me the value of void ratio? Can you just give me the value of void ratio? That is your total volume minus volume of solids upon volume of solids. I'll just also calculate. Right. So this is your volume. Total volume is your 346 upon 1.86. That is 346 upon 1.86. You are going to get it as 186.02. Right. And this particular value, how much you are getting? This volume of solids, it is 284 divided by your 2.7 value. That is 105.18. So what will be the void ratio? Void ratio, I can say it is 186.02 minus 105.18 by 105.18. Now can you give me the value of void ratio? Rakesh, can you just tell me what is the value of void ratio? It will be your 0.768. 0.768. This is your void ratio. Right? Now we need to find out the degree of saturation. We need to find out the degree of saturation. We know that S into E, it is equal to W into G. S into E is equal to W into G. Right? This S value we need to find out. This E value we have, that is your 0.768. That is your 0.768. Now, this water content, I can find it as weight of water upon weight of solids, right? Or mass of water upon mass of solids. Or can I say it is total mass minus mass of solids upon mass of solids, right? Total mass is 346, mass of solids is 284. 346, 284. 346 minus 284 divided by 284. It is going to give you the water content value. Just let me know the value. So it is your 346 minus 284 divided by 284. It is 0.21 or 0.22 value. That is 0.22 value. So this water content we got 0.22. G value is given to me 2.7. So from here I can calculate this S value. So S value will be your W, that is 0.22 into G, that is 2.7 by void ratio, that is 0.768. 0.768. So this particular value you are getting it as 2.7 divided by 0.768. Right? That is your 76.7%. 76.7%. 76.7%, right? Rajat, for that you have to qualify the gate, right? And to qualify the gate, you have to focus on the class. Clear? That is the easiest way. Okay? So, what will be our correct answer? 76.7. Or you can say 76.8. So this is the particular answer. I hope this particular question is clear to you. Right? Is this particular question clear? Is that particular question clear? Okay. Now try to give a try on this particular question. Try to give a try on this particular question. Right? Okay. This particular question, I am giving you the homework. As this is the particular question also based on the same concept, so this will be homework for you. You can just take a screenshot of this particular question, right? And I want you to give the answer of this particular question in the chat box, right? In the comment box later on, you can also give the answer to this particular question. I'll just be side so that you can take the screenshot, right? So this is the particular question for your practice. It is also based on the same concept, so it is not necessary to discuss the same concept again and again, right? As we are having the concern of constant of times also, right? So try to focus here. Okay, it's better to go with the next question, and this is the particular question for you. Just read the question and try to solve. Just read the question and try to solve. Clear? So try to read the question. I'll just be out of the frame so that it will be completely visible to you. Just try to read the question. So what this question says, the question is saying that a 1220 meter long embankment having a width of 7.5 meter and of 0.8 meter having a compacted thickness to be constructed in a part of roadway project. Specification required for the road compacted to the moisture content of 19.1%, achieving a dry unit weight of 16.4 kilonewton per meter cube. Soil is to be excavated from a borrow pit where the soil has the moisture content of 15.7%. Clear? All these questions are having the most of the probability that it will be asked in your GATE 2023, right? So whatever are the questions I have picked for today, they are having most of the chances that you will get definitely a type of question in your GATE exam, right? And these are not just easy question or hard question, they are your tricky questions. Clear? Right? And it is given that the bulk unit weight of soil in the field or in the borrow pit, it is 17.25 kilonewton per meter cube. The volume of soil to be excavated from the borrow pit is, you remember we have discussed, if there will be a question in which you are constructing an embankment and you are taking the soil from a particular borrow pit, in that particular case there are the concept that your weight of solids and volume of solids, that will be constant. So based on the data you have to see that this particular condition, right, the condition number is 1 for embankment, your condition number 2 is for borrow pit. So out of these two, how to compare these things, either based on your weight of solids or on the based on your volume of solids, that you need to figure out, right? Other process we already know. So I'll just explain you the question first, then I'll give you some time, right? So it is saying that there is one embankment, which you need to construct for your highway project. Its length is given to you, its width is given to you, its thickness is given to you. It means the volume of embankment is given to you, that what is the volume of embankment or volume of soil required for this particular embankment, that is particular value is known to you. And also what are the different conditions, means what is the water content needed for there, it is also known to you, right? This is also known, it is also given. Now what is the dry density you have to obtain in the field, that is also known to you, that is also known, right? We will just see what are the data. And there is another condition, to make this embankment you are taking the soil from a pit, I am saying it as a borrow pit, I am saying it as a borrow pit. So from this borrow pit you are taking the soil so that you can construct this embankment, right? So we know that if we are taking the soil from one place to another place, there will be definitely change in water content, there will be change in void ratio. So whatever is the volume required here, it is not necessary that the same volume you have to take out from here. If it is not necessary, whatever is the volume you have to take out, this is the particular question asked to you. From here, this volume you need to find out, and gamma bulk of the soil is given to you for this borrow pit also. water content is also given to you for this borrow pit. Clear? Is that clear? So this is the particular data given to you. How to proceed with this? We know that the volume of solids here, the volume of solids in case number 1, it will be same as, the weight of solids in case number 1, it will be same as weight of solids in case number 2. Also the volume of solid in case number 1, it will be same as volume of solids in case number 2. Now the question is, to which particular value we have to compare? Depending upon the data, what you can easily compare, that you have to see. Right? Now this gamma bulk and water content here is known to me. I know that gamma D is equal to gamma bulk upon 1 plus W. It means this gamma D2 value will also be known to me. I'll say this condition as 1 and this condition as 2. It means gamma D2 value is also known to me. I know that gamma D is equal to what? Dry weight upon total volume of soil. Or what we have seen, this dry weight of soil, it is equal to your weight of solids. Weight of solids upon total volume. Clear? We know that it is weight of solids upon total volume. So from here, can I say that weight of solid of 1, it is equal to what? Gamma D1 into V1. Gamma D1 into V1. And it will also be equal to gamma D2 as weight of solids is constant into V2. Gamma D2 into V2. Right? Now try to focus on this. Now try to focus on this. Gamma D1 is known to me. V1 is known to me. Right? Gamma D2 value is, we have calculated, and we need V2 value we need to find out. And V2 value we need to find out. Right? Yeah, in tomorrow's session from 6 p.m. to 9 p.m. we will also cover this foundation engineering also, right? So definitely we are going to cover the foundation engineering also. Clear? First we have to focus on the basics of soil mechanics, then only we can jump to your foundation part, right? So don't worry, the particular geotechnical engineering, it will be covered here. Clear? So now can you find out what is the V2 value? This is the only unknown. Now this is the only unknown. Can you calculate? I have explained you the question. You just need to put the values now. You just need to put the values now. Give me the value of gamma D2. Give me the value of gamma D2. That is gamma bulk upon 1 plus W. Right? This is your bulk unit weight of borrow pit. This is the water content of borrow pit. 17.25, 15.7. 17.25, 17.25, 15.7. That is 0.157. Right? Give me the value of gamma D2. Just give me the value of gamma D2. Fast. So gamma D2 value, I am obtaining it as 14.91. 14.91. 14.91. Just check the value. That is kilonewton per meter cube. Kilonewton per meter cube. 9874. 9874. Okay, one answer we are getting it as 9874. Option number A. Okay. That is 14.91, right? So gamma D2 is known to me. Now, gamma D1 is also known to me. What was this gamma D1 value? Dry unit weight of soil. Dry unit weight of soil for the embankment, that is 14.4. This value is your 14.4. Right? Unit is kilonewton per meter cube. What is this volume? V1 value 1220, 7.5 and 0.8. 1220, 7.8 and 7.5 and 0.8. 7.5 and 7.5 and 0.8. how much volume we are getting? This volume is your 7320. 7320. This volume is your 7320. Right? Thank you, Subodh. Okay. So it is V1 is your 7320 now. Gamma D1, it was your 14.4. 14.4. V2 value we need to find out. Gamma D2 we have calculated as 14.91. Right? 14.91 kilonewton per meter cube. This was your in meter cube. Right? It is your kilonewton per meter cube. So I can say that 7230 into 14.4, it is equal to V2 upon gamma D2, that is your 14.91. So what is the V2 value you are getting from here? V2 value. Yeah, thank you, Kanu. It is your 8051.5. I am getting it as 8051.5 meter cube. Just let me know if the same answer you are getting or not. V2 value 8051.5, right, or 8054.7. Okay, Amit is getting it as 8054.7. Clear? So which one will be our correct answer? 8051.5. 8051.51. Right? We can say this is our particular correct answer. Just let me know if there is any doubt to this particular question. Right? So this type of concept, it is generally asked in your GATE exam. It should be known to you. Just let me know if it is clear or not. Clear, right? Is this clear? Right? I'll just explain you for the Hindi audience also. क्या दिया हुआ था हमें क्वेश्चन में? हमें क्वेश्चन में एक एम्बैकमेंट गिवन था. उस एम्बैकमेंट का हमें लेंथ गिवन है, हमें विड्थ गिवन है और थिकनेस गिवन है. इसका मतलब हमें पता है कि कितना वॉल्यूम ऑफ सॉइल है इन दैट पर्टिकुलर एम्बैकमेंट. इसके अलावा हमें ड्राई यूनिट वेट दिया हुआ है सॉइल का, वाटर कंटेंट दिया हुआ है सॉइल का. ये वैल्यूज हमें दी हुई है फॉर एम्बैकमेंट. अब ये एम्बैकमेंट को कंस्ट्रक्ट करने के लिए हमने सॉइल को एक पर्टिकुलर प्लेस से लेके आए. उस प्लेस को हमने कह दिया बोरो पिट. बोरो पिट की भी आपको स्पेसिफिकेशन दी हुई है कि वहां पर जो सॉइल है उसमें वाटर कंटेंट कितना है 15.7 और वहां पर जो उसका बल्क यूनिट वेट है दैट इज 17.25. अब जब आप सॉइल को कैरी करोगे एक पोजीशन से दूसरी पोजीशन पे, सो कुछ ना कुछ वॉइड्स में चेंज आएंगे, कुछ ना कुछ वाटर कंटेंट और आपके पास वॉइड रेशियो में चेंज आ सकता है. राइट? आप देख भी सकते हो यहाँ पर वाटर कंटेंट था 15.7 और यहाँ पर वाटर कंटेंट है 19.1. तो आपसे कह रहे हैं कि अगर आपको इस पर्टिकुलर स्पेसिफिकेशन का एक एम्बैकमेंट कंस्ट्रक्ट करना है तो इसके लिए कितना वॉल्यूम ऑफ सॉइल आपको बोरो पिट से कैरी करना पड़ेगा. सो द करेक्ट आंसर इज योर 8051.5. सो ट्राई टू सी. राइट? हियर द पर्टिकुलर वॉल्यूम वाज 7320. सो टू मेक अ एम्बैकमेंट ऑफ volume 7320 you have to take 8051.5 meter cube of soil from the borrow pit. I hope this is clear. Right? तो कैसे प्रोसीड करना है इस टाइप के क्वेश्चंस को? ट्राई टू सी दैट यू हैव टू कंपेयर इट ऑन द बेसिस ऑफ आइदर वॉल्यूम ऑफ सॉलिड्स और वेट ऑफ सॉलिड्स. अब आपको ये देखना है कि कौन सा पार्ट इजी है आपको कंपेयर करने में. क्लियर? राइट? जनरली इस टाइप के क्वेश्चंस में जो आपके पास मोस्ट इंपॉर्टेंट फॉर्मूलाज हैं जो कि आपके पास यूज में आएंगे, दैट इज योर फर्स्ट इज गामा डी इज इक्वल टू weight of solids upon total volume. So from here also you can compare the weight of solids, that is gamma d into volume. Other than that, we know that weight of solids is equal to total weight upon 1 plus water content, right? So from here also you can compare the weight of solids. For volume of solids, we know that it is total volume upon 1 plus void ratio, right? So these are the some important formulas which are generally used in this type of particular question. Clear? Thank you, Himanshu. Okay, thank you, Amit. I hope this is particular concept is clear to you, right? Okay, now try to see the next question. This is also a very good question, right? This will clear your basics of the phase diagram. Now try to read the question and give me the answer. A very good question. If you know the shrinkage limit concept, if you know how to find out the shrinkage limit, this particular question, it will be okay. Yeah, it will be very important for you. Hi Chandu, good evening. Good evening Chandu, I can remember you from the online classes, right? Okay. So you should be able to answer these type of questions. Okay. Try to read the question and find out what this question says. The question says that the natural moisture content of a fully saturated clay is 30%. The shrinkage limit of clay is 25% and specific gravity of soil is 2.65. The percentage reduction in unit volume of clay when the moisture content reduced to 15% by evaporation. Right? So what this question says, in a natural state, your water content is what? 30%. Moisture content is nothing but your water content, right? Your shrinkage limit is 25%. Okay, sir, we remember that at shrinkage limit, your soil will be just saturated, right? So it means at 25% your soil was just saturated. At 30% also it will get saturated. If you will add more extra water, at 25% your all voids of soil, they get saturated with water. But if you will add some more water to that, again that particular soil will be your saturated soil only, right? So 30% is also your soil is saturated. At this 25% also your soil is saturated, as this is your shrinkage limit. Now it is saying that from this natural state, you have reduced the water content to 15%. You have evaporated the soil and the water content, it get decreased from 30% to 15%. Right? When you have dried the soil, there will be definitely change in volume also. What will be that change? It is asked to you. It means it is asking for the percentage reduction in unit volume. So it is asking for delta V. Delta V. It means corresponding to 30%, if my volume is V1, corresponding to 15%, if my volume is V2, so it is asking for delta V, that is V1 minus V2 by V1 into 100. That will be your percentage reduction in volume. That will be your percentage reduction in volume. Himanshu is giving the answer as 11.45. Okay. 13.27 A. So we are getting C answer also. We are getting A answer also. What about other students? This particular question, it will take time, right? Take a time of 1 minute and try to solve this particular question. Definitely this particular question, it will give you a good insight of how to use that phase diagram, right? Just try to see that what value you can find out. I have given you that. You have to find out this V1 value, V2 value and V1 value. Only void ratios are, only water contents are given to you, right? Just try to give me the answer. Just try to give me the answer. Okay. Okay. Should we proceed? Okay, now try to see. Initially, this is your stage. Okay. Initially, this is the condition you are having, right? This is your soil. it will be consisting of solids and water, as it is fully saturated, right? In this particular case, if I say this is the volume, this is nothing but V1. These solids, let's suppose its weight is weight of solids, right? And this is your weight of water in 1. I know that for first case, water content is what? 30%, or I can say it is 0.3, or I can say that water content is nothing but weight of water upon weight of solids. 7.38. Rakesh is saying 7.38. Okay, just check. So this, can I say this? Weight of water in 1, it is nothing but equal to 0.3 times of weight of solids. 0.3 times of weight of solids, right? Similarly, if I draw the second condition, right? What is the second condition? Now you have reduced the water content to 15%. Now you have reduced the water content to 15%. So let's suppose now this is the particular phase diagram. Now water content is less than your shrinkage limit. It means now your soil is not saturated. It is not now completely saturated at 15%, right? So what we can say, okay, now this particular soil, it will contain solids, it will contain water and air, right? This is for your second point. Here water content is what? 15%. And its volume is what? Its volume is your V2. This is what we have said. This volume is V2. Can I say that weight of solids, it is going to remain constant? This weight of water, similarly, just we have said that it is 0.3 times of weight of solids. Here also I can say that this weight of water in 2, it will be your 0.15 times of weight of solids, and weight of air, we generally take it as 0. One more condition is given to us. Now you can see that there is a change in volume. This is your delta V. When you have reduced the water content, there is a delta V, change in volume. There is one more condition given to you, that is shrinkage limit. Related to shrinkage limit. Now we know that below shrinkage limit, if you will reduce the water content, there will be no change in the volume of soil. So I can say that this is the solid and this is complete water, right? If this volume is V2, it means this volume is also V2. This volume will also be V2, as below this particular shrinkage limit, if you will reduce the water content, there will be no change in volume, right? And here the water content is what? This is for your 25% of water content. Let's say this is your weight of solids, that is not going to change, or here your weight of water will be equal to, in condition number 3, it will be equal to what? 0.25 times of weight of solids. Up to this particular point, is there any doubt? Just see and let me know. Is it clear to you? Right? Now, try to find out this V1 value. Can I say that this V1 is equal to, if this volume of solid is Vs, So can I say that this is volume of solids plus this volume of water? This volume of water in 1, volume of solids plus volume of water. Can I write it as, I know that gamma value, it is weight by volume. Gamma is equal to weight by volume. So I can say that volume is equal to weight upon gamma value. That will be weight upon gamma value, right? So I can write it as weight of water in 1 upon weight of water upon gamma W1, right? And weight of water is nothing but equal to 0.3 times of weight of solids, right? This is your V1 value. This is your V1 value. If I further write it as, I can write it as weight of solids plus gamma W. Now, we can assume in which units we are taking it as weight and volume. Let's suppose if I am taking weight in terms of gram and volume in terms of your centimeter cube. Can I say that gamma of water in that particular case will be equal to 1 gram per cc? Or can I say if weight is in my grams and volume is in centimeter cube, your gamma of water is going to be equal to 1. So it means your V1 value, it will be volume of solids plus volume of water, sorry, weight of water in 1, that is 0.3 times of weight of solids. 0.3 times of weight of solids. Similarly, from this diagram, I can say that V2 value is nothing but equal to volume of solids plus 0.25 times of weight of solids. V2 will be equal to volume of solids plus 0.25 times of weight of solids. Now we are having V1 value, we are having V2 value. It will be easy for us to find out the delta V, right? So if I find out what is the change in volume, so change in volume, percentage change in volume, it will be equal to V1 minus V2 upon V1 into 100, upon V1 into 100, right? Now try to focus. V1 value is your Vs plus 0.3 times of Ws. Sorry, Vs plus 0.3 times of Ws minus V2 value is your Vs minus 0.25 times of Ws, clear, divided by V1, that is Vs plus 0.3 times of Ws, clear. It means, can I say that this particular value, it will be get cancelled out, multiply by 100. It is 0.3 minus 0.25, that will be 0.05 multiply by 100. It means 5 times of weight of solids divided by volume of solids plus 0.3 times of weight of solids. If I take this weight of solids in the denominator, right? So from here this weight of solid will be removed and we can divide this particular equation with weight of solids. So it will be 5 upon volume of solids upon weight of solids plus 0.3 plus 0.3, right? Can you tell me this particular value? Can you tell me this particular value? We know that G is equal to gamma of solids upon gamma of water. If gamma of water we have taken it as 1 gram per cc, right? It means G value is your gamma s upon, sorry, gamma of solids, and this gamma of solid I can write it as weight of solids upon volume of solids. But this is your volume of solids upon weight of solids. It means, can I say that this particular value, it is nothing but 1 by G. It is nothing but 1 by G, right? So if I calculate this delta V value, it will be 5 divided by 1 by g. Now specific gravity is known to me. Specific gravity is known to me 2.65. 2.65. 2.65. Right? Plus 0.3. Plus 0.3. Can you give me what is the percentage volume change when you have reduced the water content from your 30% to 15%, right? But we have calculated it from 30% to 25%. Why? As we know that below shrinkage limit, if you will reduce the water content, there will be no change in your volume of soil, not in the volume of voids, not in the void ratio or porosity, right? So that particular concept we have used here. Just give me the value, change in volume. How much value you are getting? Just calculate this. Rakesh, what is the value you are getting? It is 5 divided by 1 upon 2.65 plus 3. Just also focus on the other points. If at any particular point you feel there is any doubt, just let me know. What is the final value you are getting? I am getting the final value as 7.38. I am getting this final value as 7.38%. I am getting this final value as 7.38%. I hope this particular question is also clear to you. Just let me know if this particular question is clear or not. Clear, right? Okay. Okay. So, should we move to next point? So, we have covered our 3 chapters, right? We have covered our classification also. We have covered, in classification I am not going to show any question, right? It will be something easy for you, right? There will be definitely a particular type of question either from the particle size distribution. Clear? Okay. Thank you, Amit. Next part, we are going to see the effective stress, permeability and seepage, right? This is also very important part of your syllabus. Effective stress, permeability and seepage. Clear? Now, what is this particular effective stress? What is your effective stress? Now, in this particular chapter, we are going to see that what will be the stress value at any particular depth below the soil due to the self weight of soil or any particular surcharge load, right? So, let's suppose this is your ground level. Let's suppose this is your ground level. Yes, you can directly use the formula also, right? I have given you the formula also for the shrinkage limit. From there also you can find out that V1 minus Vd, right? If you remember in that particular formula, there is one term V1 minus Vd, right? So, from there also you can find out. Clear? But just for the concept that how this phase diagram can be used, just we have elaborated that. Clear? As sometimes it is not necessary that you will remember the formula, so from the concept also you can go. Clear? Otherwise, yeah, directly from the formula also you can go. Clear? So, in the classes, in the online and offline classes, we have given the direct formulas also. From there also you can proceed with this, right? So, yes, let's suppose this is your ground level, right? And let's say this is your, I'll just also draw the water table so that all the effect can be seen here. Let's suppose at the same point you are having your water table. Clear? And at any particular depth, you need to find out that what are the different stresses due to this self weight of soil, and there can be any surcharge load, right? Let's suppose there is a snowfall over this particular land, right? So, that will be your surcharge load, or we generally represent this surcharge in terms of stresses only, right? Or pressure value only, right? So, let's suppose this is surcharge is Q. This soil, it is having a unit weight as gamma, right? Sorry, this soil is having its property as unit weight as gamma, and this depth is, let's suppose Z. Let's suppose Z. We know that the stress value at any particular point, it will be due to this weight of this particular soil and this superstructure load, right? Now try to see. If I need to find out what is the stress value at this P, we have three terms, right? One is your total stress, one is your total stress, we represent it with sigma. So what will be total stress? Total stress will be the weight of that particular material above this particular point, the stress value because of that, right? And stress value, that is nothing but the gamma of material multiplied by the depth of that particular material. Gamma of material multiplied by depth of that material. So if I say this is the particular soil having unit weight, having gamma value as gamma saturated, as this particular soil will be saturated, at complete soil will be below water content, below your water table, right? So this particular soil, it is your saturated soil, right? So if I have to calculate the total stress means one is the stress due to this particular weight of soil. How to write that particular stress? That will be gamma of this soil. This soil is your saturated. Saturated means it is having the weight of solids plus weight of water. It is having the weight of solids plus weight of water. So I can write it as gamma saturated into this Z value. Clear? And there is one more stress from the top, plus Q, right? Similarly, if I want to find out what is the stress value at that particular point only due to the weight of water. Now, if I insert one piezometer here, if I insert a piezometer here, the water, it is going to rise up to this particular level, right? It means this is nothing but Z value. It means water is available up to this particular depth. So I can say that this particular stress, we call it as a pore pressure or pore water pressure, represented by U. That will be, what is the gamma? Gamma of material for which you are calculating the stress. Here now material is my water. So can I say it will be your gamma of water into Z value, into Z value. Clear? Now there is another term, that is effective stress. That is effective stress. That is your effective stress. That is sigma bar. Clear? Now we know that at any particular particle, the water pressure, it is acting equal from all the directions. That's why we also call it as neutral pressure, right? So it means this particular pressure, it is not responsible for the particles to come into closer contact, right? If it is not responsible for particle to get into closer contact, it means it is not going to influence most of the properties of soil. Clear? Like permeability of soil, we are going to discuss later. Permeability of soil is how easily water can flow through the voids of soil. Similarly, if the particles will be closer, the strength of soil will be more. It means this particular stress value, it is also not responsible for the strength in the soil, right? So for that, Terzaghi has given one concept of effective stress, right? That's why we call the Terzaghi as father of soil mechanics also. You might have heard this particular name, right? Terzaghi, that is Carl Terzaghi, that is father of your soil mechanics, right? So they have given the concept of this effective stress. Clear? Now, effective stress is what? The stress which get transferred by the grain to grain contact of solids. It means this is that particular value of pressure which get transferred through the solids only. It means we are neglecting the pressure due to water. So can I say that it will be equal to total stress minus pore water pressure, right? What is your total stress? That is gamma saturated into Z plus Q minus gamma W into Z. This gamma saturated minus gamma W, we call it as gamma submerged. Gamma saturated minus gamma W, it is our gamma submerged, right? So can I say it is a gamma submerged into Z plus Q value, right? Or also we have explained previously that if there is a water at this particular level, this particular soil having a weight due to this saturated weight, but there will be one buoyancy force in upward direction, right? So your weight of solids, it is going to get decreased. The weight of solids, it is going to decrease, and it will be given by now submerged unit weight of soil. So here you can see when you have taken the total stress, it was gamma saturated into Z. But when you are taking into account the effective stress, it is your gamma submerged into Z. Clear? So this is how we calculate the effective stress. Now, the things you need to remember in this particular chapter is, one, when there is fluctuation in water table above ground level, let's suppose this is your ground level and this is your water table. Initially, let's suppose this was the water table, right? And this water table in any other season, this water table decrease to this particular value, or it may also increase sometimes. In another season, it get increased. Clear? So whenever there is a fluctuation in water table above ground level, there will be no change in effective stress. Clear? So you can remember this concept. In this particular, there will be no change in effective stress. No change in effective stress value. Clear? So sometime effective stress you can write like this. In some books, you will also find out this symbol. So both are the symbol used for your effective stress. So this is the first concept what we have discussed. If there is any change in the water table above ground level, there will be no change in the effective stress, right? So sometime examiner asks you some types of questions where this type of condition will arise, like in river. You can see in river, your water table, it is above ground level. So if the level of water it is changing in different season, there will be no change in effective stress at any particular depth. Why? As you know that if water table is decreasing or increasing, your total stress and pore water pressure value, it is going to get deviated by the same amount. So effective stress, it is finally going to remain same. Clear? Second case, what we see, if this is the particular ground level and water table is below ground level. Let's suppose initially this was the water table, right? Now, let's suppose in any other season this water table rises by h height. Rises by h height, right? So it is rise. So when there will be a rise in the water table below ground level, your effective stress value, it is going to get changed and it will get decreased, right? So effective stress value will get decreased by what amount? By gamma bulk, right? I am just taking the symbol only, so it will be gamma bulk minus gamma submerged into H, right? It is going to get decreased by this particular value, gamma bulk minus gamma submerged into H, right? That also you can see that initially this soil was having a bulk condition, right? When there is no increase in water table, this particular height of soil, it was in bulk condition. Now when this water table rises, the unit weight of this soil, it is going to be now gamma submerged, right? As I know that gamma bulk is more than gamma submerged. Gamma bulk is more than gamma submerged. So definitely there will be decrease in weight. If there is decrease in weight, it means there will be decrease in effective stress. Similarly, if your water table it get lowered, if water table get lowered by h height, right? So here there is lowering of water table. So your effective stress going to get increased by same amount, right? That will be your gamma bulk minus gamma dash into H. I hope this concept is clear, right? Sometime examiner also ask that if there is sudden lowering, when I am saying this lowering, it means this lowering is gradual. This is your gradual lowering. Sometime what happens that you have suddenly lowered the water table. When there is a sudden lowering of water table, if there is sudden lowering of water table, remember that again your effective stress, it is going to increase, but this time the value will be gamma saturated minus gamma bulk into H. Gamma saturated minus gamma bulk into H. Clear? So these three concepts you should remember. Next, there are other concepts also related to your, if there is a effect of capillarity and all, right? So those you can just revise. If I just talk about, okay, capillarity also, that is the important part, right? So we know that due to capillarity, let's suppose this is your ground level. If I talk about the case of capillarity, let's suppose this is your ground level, right? We are just going to see that quickly, that whatever we have studied in the last 6 or 7 months, right? Let's suppose this is your ground level and this is your water table. Let's suppose this particular soil, it gets saturated due to capillarity. It gets saturated due to capillarity. Clear? We know that this particular soil which gets saturated due to capillarity, it will be in the saturated condition but not in the submerged condition. A particular soil, it will be in submerged condition only when it is below the water table, right? This is your water table, this is the rise in capillarity. Now due to this capillarity, what will be the change? The change will be this particular capillarity, it will give you a negative tension or it will give you a negative pressure, as we generally take this particular stress value, compression as positive. Due to this particular capillary, there will be tension on the solids, right? So if I represent this side as, compression, this is your compression part, positive, this will be your tension, right? This is the distribution of your pore water pressure. This is the distribution of pore water pressure. So due to this capillary water, there will be change in pore water pressure. We know that the pore water pressure value, it will be 0. This particular point will be at this particular level, right? We know that at water table, your pore water pressure, it will be 0. As you are moving down to the water table, your pore water pressure, it will be compressive. So I am taking compressive as positive. Above water table, as this particular water, it is held by the solids, right? It will be in tension, so it will give you the negative pressure. So let's suppose if this rise in height, it is Hc. So what will be this particular value? This will be your gamma W into Hc, right? Similarly, you know that if this height is Z, so this particular value will be what? Gamma W into Z. Clear? And generally we take that pressure as negative. So it means this pore water pressure, this is giving you the negative pore water pressure. We know that effective stress is total stress minus pore water pressure. So pore water pressure, it is subtracted from total stress. This is your negative pressure. So from here we can analyze that your capillarity, it increases the effective stress of soil. Your capillarity, it increases the effective stress of soil, right? So if it is asked that what is the behavior of capillarity or what is the effect of capillarity on the effective stress of soil, so your effective stress of soil is going to increase due to rise in capillary. Clear? Other than that, okay, we can also discuss about the permeability, right? So what is this permeability? What is this permeability? So we know that permeability, it represents the ease with which water can flow through the voids of the soil. How easily water can flow through the voids of soil, that will be represented by your permeability. Also this permeability represents the resistance which is offered by the solids, to your particular water, right? If more resistance is offered by the solids when water is flowing through the soil, your permeability will be less. If resistance offered by the solids, it is less, your permeability will be more, right? So in this sense also you can understand the permeability. What is this? It is the easiness, or you can say it is the ease with which water can flow through the voids of soil. With which water can flow through the voids of soil. Water can flow through voids of soil. Clear? Now, when the water is flowing through that particular medium, like in our case through the soil. This can be analyzed by your Darcy's equation. That can be analyzed by your Darcy's equation, right? Or we also call it as a Darcy law. This law having two important assumptions. One is it is valid for saturated soil. For saturated soil, and the flow of water is laminar flow. Laminar flow. Clear? In that particular case, what this says that the velocity of water which is flowing, it is directly proportional to hydraulic gradient. It is directly proportional to hydraulic gradient. What is this hydraulic gradient? Let's suppose this is your soil sample, right? This is your soil sample, and water is flowing from here to here. It means if we talk about the head, let's suppose the water is having this particular energy here. So generally in water, we represent the energy in terms of head, right? That is your energy per unit weight. So let's suppose here it is, the head is H1, and when this water reaches to here, it will lose some of its energy. So definitely there will be decrease in head. Let's suppose this head is your H2 value. Clear? It means there is decrease in head, or there is loss of head. Clear? This is your head loss. If the length of sample through which this head loss has occurred is L, if I need to find out what will be the head loss in a unit length, what will be the head loss in a unit length? So what I can say it will be HL by L. So that HL by L is nothing but your I value. That is your hydraulic gradient. That is your hydraulic gradient. Clear? So according to Darcy's law, V is directly proportional to I. If we remove this proportionality sign, there will be one coefficient, that is coefficient of permeability. That is V is equal to Ki, where K is your coefficient of permeability. Coefficient of permeability. Clear? Right. So when we calculate this particular velocity value, this particular velocity is not your actual velocity. We call it as a discharge velocity. Discharge velocity or average velocity. Clear? As while calculating this velocity, we have taken the total area of soil. We have taken the total area, cross-sectional area of soil through which this water is flowing. If I talk about this particular cross-section of the soil, right? If I take a cross-section from here, so let's suppose this is the particular cross-section. So while calculating this velocity value, we have taken that the water is flowing through this particular area of the soil, which is not true, right? As we know that this particular area, it will also consist of the solids, and it will also consist of voids, and water is only flowing through the voids of the soil. Clear? So the actual velocity, or we call it as a seepage velocity, that is Vs, it is given as V upon porosity into S. As we have taken the saturated soil, it means S value will be 1. So we can also write it as V by N. Clear? So V is your average velocity, Vs is your actual velocity. So whenever you have to deal with the actual velocity of actual velocity of water through the voids of the soil, you have to take this Vs value or seepage velocity in account. I hope this concept you can remember, right? I have just given you the insight of this particular point also. So this is our coefficient of permeability, right? So based on this particular parameter, we are going to define the particular soil, if it is having a high permeability or low permeability. Clear? Now for the determination point of view, we are having two methods to calculate the permeability, right? So these are our lab methods. One is your constant head permeability test. Second is your falling head permeability test. This particular test we use for the coarse grained soil, and second test is your for fine grained soil, right? What we do, we mainly provide a constant head through the soil. The water will flow through this particular soil, right? As we have taken it as a constant head, your head loss is going to remain constant. And what we do, we collect a particular discharge which is flowing through this particular soil in a particular given time, right? So what we will get? We will get how much volume get collected in a particular time. This is the reading which we are going to get from this particular test. What is the volume collected in a particular time? The area of sample will be known to us as we have prepared this particular sample. The length of sample will be known to me, right? So by this particular test, we can say that your permeability, it will be equal to, you can remember it like that, K will be is equal to log upon hat. If this head loss is HL, A into T, right? So V is the volume you have collected in time T, L is the length of sample, HL is the head loss, and A is the cross-sectional area of this particular sample, right? So by this particular test, you can find out what is the permeability value. So try to remember or try to analyze that, okay, this particular test, we are not getting directly K value. We are getting this volume and time. It means examiner can give me the data of this volume and time and can ask me this permeability value, right? So you have to remember this particular formula. If we talk about the falling head test, as in this particular type of soil, as in this particular test, if we are using it for your fine grained soil, it will be very difficult to get a particular volume of water in a given time, right? It will take too much time to collect a specific particular or sufficient volume, right? So for that, what we do, we mainly go for the falling head permeability test, right? So there will be a standpipe, small standpipe, and in that we take in a different time how much there will be change in head, clear? And based on that, we give the formula K is equal to 2.303 area of standpipe small a into length of sample, that is L, upon capital area, that is area of your sample, into the given time in which your head it reduced from H1 value to H2 value. Reduced from H1 value to H2 value. So what are the readings you have to take in this particular case? In given time, you have to take that how much head get decreased from a particular value to H1 value to H2 value, right? So these are the reading. It means these reading will be given to you by the examiner, that is H1, H2 and T, clear? If you are conducting this particular test for H1, you got the H1, H2 and H3 value in the same time T, so there is one relation that H2 will be is equal to under root of H1 into H3. H2 will be is equal to under root of H1 into H3. You can just derive it from here also, as in both the cases permeability will be same, but just to get the quick response, you can remember also this particular formula, right? So the middle value, it will be is equal to under root of H1 into H3, clear? Up to this particular point, is there any particular doubt? Is there any doubt? Rakesh, are you there? Just show your presence if you are there. And all other students also, if you are live, just give me a comment, right? Okay. There are also, okay, yes. Okay, Chandu, right? Other than that, we are having different field methods also, right? And we are having empirical relations also, like Koznick-Karman equation we have Allen-Hazen equation for the calculation of permeability. Those formulas also you can remember, right? Another important topic from this particular permeability is calculation of permeability in stratified soil, right? As generally we know, in nature, the soil will be in the different stratas. It is not like that you are getting a homogeneous and isotropic soil, clear? So for that, we do the analysis in two cases. One, when there is a flow parallel to the bedding planes, right? So these are the different soil. These are the different soil. These are your bedding planes. Clear? These are your bedding planes. So these are particular bedding planes. Here the head is more, here the head is less. It means water is flowing from here to here. If we see, these are the bedding planes and water is parallel to the bedding planes. Water is parallel to bedding planes. if your water is parallel to bedding planes, your equivalent permeability of soil, it is given by summation of K into H upon summation of H. Summation of K into H upon summation of H. Also, in any particular case, if these are your bedding planes, right, these are your bedding planes, and you can see that here the level of water is more, or head of water is more, here the head of water is less. It means water is flowing from higher head to lower head, we know. Here you can see that the water is flowing perpendicular to bedding plane. So whenever there is a flow perpendicular to bedding plane, never remember horizontal or vertical. Never remember water is flowing horizontal or vertical. It will depend upon the orientation of your bedding planes, right? So always remember if water is parallel to bedding planes or perpendicular to bedding planes. If it is parallel to bedding planes, your equivalent permeability is summation of K into H upon summation of H. If it is perpendicular to bedding plane, your K equivalent, it is given as summation of H upon summation of H by K. Summation of H upon summation of H by K. Clear? I hope this particular concept is also clear. I hope this particular concept is also clear. Right? Okay, next if we move, before this particular question, I will also just explain the seepage theory, right? Seepage analysis. Seepage analysis. As we know that water is seeping through the voids of soil, the velocity of water, it is going to be very less. So generally the total head in water or total energy in water, we take it as datum head plus your head due to water, right? Now try to remember, this is your datum head, this is your pressure head. Clear? In any particular soil, if you need to find out the datum head, this is the particular height of the concerned point from the datum, right? And datum you can assume it anywhere. Let's suppose if there is this particular soil sample having a length L. Clear? I need to find out. I'll just show you the waters also so that it will be clear. Let's suppose this is the water level here, and here the water level is this. Here the water level is this. Clear? If I assume this as a datum line, I want to find out what is the datum head at this particular concerned point A. What is the datum head at this particular concerned point A? Can you tell me what will be the datum head at A? What will be the datum head at A? Just tell me for this particular case, what will be datum head at A? If this is the particular datum, if this is your datum, this length is L, what will be datum head at A? So datum head is your, yes, it is going to be L, right? It is not H1, it will be L. Datum head is the height of concerned point. Remember, it is the height of concerned point from the datum, right? So from datum, what is the height of concerned point? My concerned point is A, so its height from the datum is L. So can I say Z1 is equal to L? Can I say Z1 is equal to L? Second thing is your pressure head. How to find pressure head? Pressure head, it is the height of water. Remember, it is the height of water above the concerned point. It is the height of water above the concerned point. So what is the height of water above this particular concerned point A? What is the height of water above this concerned point A? Can I say the water level at this particular A? If you will put one piezometer here, up to whatever depth, water level will rise. Up to whatever depth, the water level will rise. That is going to be your pressure head. It will rise up to h1 height. So your y1 will be h1. Your y1 will be h1. I hope it is clear. So how to find out the datum head, how to find out the pressure head, right? Similarly, let's suppose this height is h2 and this concern point is your B point. Okay, now I want answer from you. What will be ZB value? What will be datum head at B point? What will be the datum head at B point? Just I want answer from your side. What will be the datum head at B point? Yes, if I talk about datum head at B point, it will be the height of this concern point above datum, but datum is also at this particular level. It means the height of this B point is 0. So my datum head will be 0. What will be YB value? What will be your YB value? What will be your YB value? Tell me. What will be the pressure head at point B? This is the level of water above that particular point. So if I put a piezometer, this is nothing but a piezometer. If I have put a piezometer at this particular B point, so my height of water is h2. My height of water is h2. Clear? So it is not difficult to find out the head of water at starting point or entry point, right, and at exit point. But what if I say find out the value at this particular point C? Find out the value at this particular point C. What will be your answer now? What will be your answer now? At point C, if I need to find out the ZC value, what will be your answer? I need to find out what is the datum head at point C. Just let me know. It will be L minus Z. Everyone agree with Prashant? Yes, it will be L minus Z. So whatever is the height, this is the height, right? So this height is nothing but L minus Z. So it will be L minus Z. But can you tell me what will be the pressure head at this particular point? What will be the pressure head at this particular point? What will be the pressure head at this particular point? What will be the pressure head at this particular point? So the pressure head at this particular point, you will not be able to find out it directly. You cannot say it directly, right? So for that you have to do now calculations. What type of calculation? I know that, let's suppose this particular change in water level is HL. So this is your head loss, right? I know when the water is flowing from soil from A to B, as you can see water is flowing from A to B, there will be a head loss. How much head loss is there? There is a head loss equal to HL. So can I say that I, hydraulic gradient, that will be HL upon L? That will be HL upon L. Yes or no? I is your how much head loss has occurred in L length. Can I also take it as I will also be equal to how much head loss occur from A to C? How much head loss has occurred from A to C? Head loss from A to C divided by length from A to C, that is Z value, right? Now head loss is known to me, length of sample is known to me. Can I find out what will be the head loss from A to C? Can I find out what will be the head loss from A to C? Right? Now let's suppose at this A point my head is 50. At A point my head is 50 and I have calculated how much head loss is there between A to C. Let's suppose between A to C the head loss is 20, right? Let's say the head loss between A to C is 20. Now can you tell me what will be the head at point C? I have given you that the total head at point A, it was 50. I know what will be the head loss from A to C. Let's suppose that value is 20. The head loss from A to C, it is 20. Now I am asking you, what will be the total head at point C? Now I am asking you, what will be the total head at point C? Just in the terms of values, can you give me? Can you give me the value? Total head at point A, it is 50. From A to C, the head loss is 20. What is the remaining head at point C? Can I say it will be 50 minus 20? Right? You have calculated the total head at A, as you know these values. You calculated the head loss from A to C. It means you can calculate what will be the total head at point C. It means you can calculate what will be the total head at point C. Right? Now, this datum head is known to you. Total head at point C is known to you. From total head, if I reduce this datum head, I am going to get what will be the pressure head at point C, yes or no? If this particular thing, it is clear to you, just let me know in the comment box so that I can proceed, right? This is the just revision. I am just saying in the terms of values only, right? I am not just going into the complete derivation part. Just let me know if it is clear or not. Otherwise, I will just explain it again. Yes, Chandu, Prashant, Rakesh, is it clear? I need to find out what is the pressure head at point C. I know what is the datum head at point C, right? Okay, try to understand. Is this clear? Is this particular value clear? It means I know that what is the head at point A, total head at point A, yes or no? Right? Is it clear? I know the total head at point A. Is it clear that I know what is the total head at point B? If I know these two values, just give me the response in the comment box so that I can just proceed, right? Whatever you will find the difficulty, I'll explain to you, right? So what are the values known to me? I know what is the total head at A. I know what is the total head at A at this particular point. The total head is HA. I know what is the total head at point B. That is your HB. I need to find out what is the pressure head at point number C. I need to find out what is the pressure head at point C, right? So, let's suppose this point C, it is at Z distance from here. It is at Z distance from here. This length is L. Clear? Can I say the head loss between A and B? Head loss between A and B, that will be what? HA minus HB. What is the total head at A minus what is the total head at B? It means HA and HB is known to me. So HL value is known to me, right? So I, it is nothing but head loss in a particular length, that is L. Head loss in a particular length, HL upon L. This I value, can I also say it will be is equal to head loss in a particular length? If I take that length is equal to Z, if I take this length is equal to Z, right? So it will be Z into whatever is the particular value, that is it will give me the head loss from A to C. From A to C. This was the head loss from A to B. This was the head loss from A to B. That's why we have taken the length from A to B. Now if I am taking the length from A to C, I can say it will give me the head loss from A to C. This HL value was known to me from here. The length of sample is known to me. I have prepared that particular sample, right? It means the head loss from A to C will be known to me. This head loss from A to C will be what? I into Z. I into Z, right? If head loss from A to C is known to me, can I say the head value at point C? Can I say that head value at point C, it will be is equal to total head at point A, total head at point A minus this head at C. Yes or no? Now is it clear now? Is it clear now? Now head loss from total head at point C. Now I can say it is total head at point A minus head loss from A to C. It will give me the total head at C, sorry. It will give me the total head at C. Now total head at C is known to me. I know what is this particular height, that is L minus Z. It means its datum head is known to me. I know that total head, it is equal to datum head plus pressure head. I want pressure head value. Total head is known to me, that is HC, minus Z value is known to me for C, ZC. So can I calculate what will be the YC value? Can I calculate what will be the YC value? Now just see and let me know if it is clear or not. Is it clear now, Chandu? Now it is clear or not? If there is any doubt, you can just let me know at which point you are having doubt. Right? Now it is clear. Okay. One more point if we see, right? We know that in particular soil, there can be seepage either in downward direction or seepage can be in upward direction. These two cases we generally consider, seepage in upward direction and seepage in downward direction, right? Now when there is a seepage in downward direction, tell me the effective stress, it is going to get increase or decrease? The effective stress due to downward seepage, it is going to get decrease or increase? Tell me. Tell me, if I am considering the effective stress at any depth Z from this top surface, right? Yes, your effective stress is going to increase, as we know that the seepage pressure, it will be in the direction of flow. It will be in the direction of seepage flow. Effective stress and the weight of soil is also in the downward direction, right? So in that particular case, I can write that the effective stress will be what? Initially it was gamma submerged into Z. I am taking that this particular soil it is underwater, right? As, or also you can write it as like this. I can just make it as like this so that it will be clear that it is a downward seepage flow, right? Now it is clear that it is a downward seepage flow, as here head of water is more and here head of water is less. Clear? So at any particular depth Z, what will be my effective stress? It will be gamma submerged into Z minus effective, sorry, this seepage pressure, it is given by I into Z into gamma W. I into Z into gamma W. Remember this Z value, we always take it from the top surface, right? We always take it from the top surface, either in the downward seepage or in upward seepage, right? Now in this particular case, sorry, it will be plus IZ gamma W, as it is going to increase, right? Both are in the same direction, so it will be plus IZ gamma W. If there is a seepage in upward direction, so what will be the condition? So submerged weight of soil, it is going to get decreased by seepage pressure, that is IZ gamma W minus IZ gamma W. So this is your effective stress value. Clear this thing? Also here we are finding out this effective stress at any depth Z from this particular surface. Now in this particular case, we know that the head at bottom, it will be more as the seepage is upward, and here it will be less. Then only we can say that there is a upward seepage flow, right? Now the entry and exit point has changed, but remember this Z value, we are taking it from the top surface. Clear? So these are the effective stress values. I hope it is clear. Now in this particular upward seepage flow, we take a special condition, that is your quicksand condition. That is your quicksand condition. Now if this gamma submerged into Z, that is your submerged weight of soil, and Iz gamma W, that is your seepage pressure value. If this seepage pressure value it become equal to the submerged weight of soil or pressure due to submerged weight of soil, your effective stress value is going to reduce to 0. If effective stress value is going to reduce to 0, right, we know by Mohr-Coulomb theory, right, by Mohr-Coulomb theory we know that the shear strength of soil, it is nothing but is equal to C plus sigma n tan phi. Sigma n bar tan phi. This is nothing but your normal effective stress, right? Now, I am taking a special case in fine sand. In fine sand, or I can say fine sand will be your cohesionless soil. In cohesionless soil, if your submerged weight of soil, that is gamma submerged into Z, or we can write first, if seepage pressure that is Iz gamma W, it will be equal to the pressure due to submerged weight of soil, that is your gamma submerged into Z. What will happen? The effective stress will be equal to 0, right? And we are talking about the fine sand cohesionless soil. It means this C value will be 0. In that particular case, the shear strength of soil also going to be equal to 0. It means your soil, it will behave like a liquid, right? The shear strength of soil, it will become equal to 0. It means your soil, it is going to behave like a liquid, right? So we call this particular concept as your quicksand condition, or when there is a seepage in upward direction, you will feel that sand is like boiling. So sometimes we call it as a sand boiling also. That particular concept we also seen at the foundation of dam. There it will cause the piping flow, right? So we also call sometime it as a piping condition. Clear this thing? Now if I talk about this particular value, so what we have seen that when your gamma submerged into Z, it become equal to Iz gamma W. At this particular point, there will be a quicksand condition. This is your quicksand condition, right? So from here, if I calculate this I value, this is the I critical value which is needed to cause this quicksand condition. It will be your G minus 1 upon 1 plus E, or you can remember it as G minus 1 into 1 minus N. Clear? If your I value is greater than, if your hydraulic gradient is greater than its critical depth, it means there will be quicksand condition. Or at equal to also you can write at that particular point it will be a limiting condition, but it will be a quicksand condition, right? Or you can say piping. This is also the check for piping. If your I value it is less than I critical, it means safe against this particular condition. For that we also calculate the factor of safety. So your factor of safety value will be IC upon I. Right? So if your factor of safety it is greater than 1, it means safe against piping. It means your soil is safe against piping, right? If your factor of safety it is less than 1, it will be susceptible to piping. Condition. Clear? So all these values, all these formulas you have to revise, right? There is one more condition which we can apply from here. We know that for quicksand condition, the effective stress is 0. Right, this is just the analysis. We know that effective stress is 0 for quicksand condition. I know that effective stress, I can also write it as sigma minus u, that is total stress minus pore water pressure is equal to 0. So from here we can also say that for quicksand condition, your total stress will be equal to pore water pressure. At just quicksand condition, your total stress will be equal to pore water pressure. So in some time of questions, we also use this particular concept, right? There is also a concept of flow net that we will see through the question only. Now it's time for the questions. Up to this particular point, if there is any doubt, just let me know. I have tried to cover all the important concepts so that you will be able to solve these questions, right? Now, try to see the question and give me the answer. If you find any particular value, just give me that particular value first. Okay, I'll just read the question for you. What this question says, a sand layer at sea floor under 20-meter water depth is characterized with gamma value as 19.5 kilonewton per meter cube. Specific gravity of soil is given to you. Assuming the specific gravity of sea water as 1.03 and unit weight of fresh water is as 9.81, what would be the total stress and pore pressure at 25-meter depth below the sea floor in the sand layer? So the condition is something like this. This is your water level, right, or sea water level, right, and it is 20-meter depth and the sand layer is 20 meter below this. Sand layer is 20 meter below this. It means this is your ground level, right? So this distance is your 20 meter. Clear? And you need to find out the stress value 25 meter below the sea floor. So this is your sea floor, this is your ground level, that is sea floor. Below this particular point, 25 meter. So at this particular level, you need to find out the total stress and effective stress value. You need to find out the total stress and effective stress value. Just calculate the values and let me know. Just calculate the values and let me know. Just calculate the values and let me know. It is an easy question, you should be able to find out, right? I have told you the concept. Now you should be able to calculate this particular value. I'll just give you the space so that you will be able to see the complete question, right? Everyone, Chandu, Prashant, try to find out. I want the answer from your side. If you are giving the correct answer, it means the concept to you, it is clear, right? Just tell me. Okay, I'll give you the hint. I need to find out the total stress at particular depth. At this particular depth, I need to find out the total stress. We have discussed that the total stress at this particular point will be due to the weight of this particular material above this. Due to the weight of this particular material, right? Try this gamma. Okay, take this gamma as gamma saturated, right? This is the soil. We know that this will be saturated soil. So gamma for this particular soil, it is given to you, that is gamma saturated. It is nothing but equal to 19.5. Clear? Now, this particular water, it is not your normal water, it is your sea water, right? And we have to use, if I need to find out the weight stress at any particular level due to this particular weight of this water, I have to consider the gamma of this particular water only. The specific gravity of this is given to you. It means gamma of this particular water will be what? Gamma W of sea water. It will be specific gravity 1.03 multiply by gamma of normal water or gamma of standard fluid, that is 9.81. Just give me this particular value. I am getting it as 10.10.1043. 10.1043 unit will be your kilonewton per meter cube. That is the gamma of water. That is the gamma of water, right? So due to this particular water, the stress will be due to this particular weight. How to find out its weight? It will be gamma W of C multiplied by 20. How to find out the stress due to this particular material? It is having solids plus it is having sea water. It means gamma saturated we can directly use. It will be gamma saturated into 25. Clear? So it will be what value? If I write the total stress, the total stress it will be gamma of sea water multiplied by 20 plus gamma saturated multiplied by 25. This particular value we have calculated 10.104. Is that the particular value? Okay, 1043 into 20 plus gamma saturated it is given to me, that is 19.5 plus 19.5 into 25. Give me the value. Give me the final result. 450.85. 450.85. 450.85 kilonewton per meter square. Right? If I talk about the pore water pressure, in the pores, which type of water is present? In pores, which type of water is present? In pores, the water which is present is your sea water, right? So, pore water pressure is due to the weight of that water present in the pores. That will be gamma W of sea water into total height. Total height is what? It is 20 plus 25. So it is what? It is your 10.1043 multiplied by 45. Give me the answer. It was 689.58. Okay, yes, it was 69. It was 6. Try to do the calculation in the right way. Right, it is your 689.5 kilonewton per meter cube, right? Okay, this particular value you are getting, right? I think this value you are getting it as 454.5 kilonewton per meter square. It will be square. Kilonewton per meter square. Just let me know. 454.69. Okay, around this particular value, right? So just check for the options. Our correct answer will be, first we need to find out the total stress. Second was pore water pressure. It means option number A will be correct. It means option number A will be correct. It is submerged, yes, but we are not asked to find out the effective stress, right? If we need to find out the effective stress, in that particular case, you have to take the submerged weight. Clear? Clear, Chandu? We did not need to find out the effective stress. We need total stress. We know that in total stress, the weight will be due to weight of solids plus water. There will be weight of solids plus water. So in that case, you have to take the saturated weight. Clear? If we talk only about the stress which get transferred due to the solids, in that particular case, what you have to consider? You have to consider the gamma submerged value. I hope it is clear. Right? Now, try our next question. Try this particular question. It is also a very good question. Clear? You will be able to calculate this particular value also. There is a capillary rise. In total stress, Y height is what? Height of water is 20 meter. See, my dear friend, if I take this total height as 25 plus 20, it means why not 25? Okay, try to see when I am taking gamma saturated. In that gamma saturated, weight of solids and weight of water I have already considered, right, for this 25 meter. The only thing I have to take is for this 20 meter now. Is that clear, Prashant? When I am taking the gamma saturated, it means it is having gamma W value also. Yes or no? It is already having the gamma W value. Clear? Yeah, right. I have used the gamma saturated. It means the weight of this particular material, either it is water plus solids, everything I have already taken into account, right? So if I am writing gamma saturated into 25, it means water is also involved in that particular calculation. I hope it is clear now. That's why we have only taken for this as gamma W into 20 and this gamma saturated into 25. Clear? Now focus on this question. Now focus on this question. What this question says? This question says that a deposit of fine sand, the water table is at 4 meters below the ground level, below the ground surface, right? But the sand up to the height of 1.5 meter above the water table is saturated by capillary rise. The sand above this height can be considered as a dry with a specific gravity is given to you, N value is given to you. Use unit weight of water as 9.81. Find out the effective stress at a depth 8 meters below the ground surface. I'll just draw the diagram for you so that it will be easy for you. So it is given that your water level is below 4 meters below the ground level. So here it is the ground level and here it is the water table, right? This is your water table. This particular distance it is given as 4 meters. But also it says that, but the sand up to the height 1.5 meter above the water table, it is capillary saturated. So up to a height of 1.5 meter. So this height is your 1.5 meter. The water is saturated, this soil is saturated with capillary. So this is 1.5 meter. So this particular value will be what? 2.5 meter, right? So this is the particular value given to you. You can consider this soil above this as a dry soil, right? So here gamma will be gamma dry. For that data is given to you, that is G value is given to you, N value is given to you, right? So we know that gamma D is equal to G gamma W upon 1 plus E. We know that gamma D is equal to G gamma W upon 1 plus E. I know the N value. I know N is equal to, or I can directly use E is equal to N upon 1 minus N. From here I can calculate the E value and I can calculate that gamma D value. So first thing is we need to find out the gamma D for this, right? And it is asking for the effective stress at a depth 8 meter below the ground surface. Below the ground surface 8 meter. This is 4 meter. So at this particular point, again 4 meter. This will be 8 meter from the ground level. At this particular point, you need to find out the effective stress value. You need to find out the effective stress value. Clear? Can you tell me this particular capillary saturated water, if you want to take the stress due to this particular weight of soil, you will use gamma saturated or gamma submerged? Again, listen the question carefully. For the calculation of effective stress at this particular point, I have to consider the weight of this soil. So weight of this soil, I will take it as a gamma D into this height 2.5. Now this particular soil, for this particular soil calculation of effective stress, you will take gamma saturated or gamma submerged. That is my question. For the capillary zone, tell me. For the capillary zone, it will be saturated or submerged? It will be saturated, right? Yes, correct, Aman. Now, tell me for this 4 meter depth, your unit weight of soil, it will be used gamma saturated or gamma submerged for the calculation of effective stress. Now it will be used submerged value. Very good, Aman. Right? So here you have to find out the submerged value. Here it is saturated value. It means the only thing we need to calculate, that will be, I should know the gamma D value, I should know the gamma saturated value, and I should know the gamma submerged value. That will be enough, right? So how to calculate this gamma D? I can calculate G gamma W upon 1 plus C. This gamma saturated I can calculate as, we know that gamma saturated, it is G plus E upon 1 plus E into gamma W. All the data is given to me, right? How to calculate gamma submerged? At in this particular part, your soil will be submerged. How to calculate submerged? It will be, I know now gamma saturated, I can subtract the gamma W from that. I can subtract gamma W from that. I will get the gamma submerged value. So what will be the stress at this particular point? Stress at this particular level, it will be gamma D into 2.5 plus gamma saturated into 1.5 plus gamma submerged into 4. Gamma submerged into 4. Clear? Now try to calculate fast. It is your duty now to calculate this value. This is the effective stress at 8 meter depth. This is the effective stress at 8 meter depth. Is it clear? First tell me, is there any doubt in this particular question, or is it clear to you? यहाँ तक कोई डाउट है किसी भी स्टूडेंट को? राइट, फॉर द हिंदी ऑडियंस आई जस्ट एक्सप्लेन इट अगेन. हमें इफेक्टिव स्ट्रेस कैलकुलेट करना है इस पर्टिकुलर पॉइंट पे, राइट? अब इस पर्टिकुलर पॉइंट पे जो इफेक्टिव स्ट्रेस होगा, दैट विल बी ड्यू टू द वेट ऑफ मटेरियल अबव दिस. इस पर्टिकुलर पॉइंट से ऊपर जो सॉलिड की वजह से, वाटर सॉलिड की वजह से जो आपके पास स्ट्रेस ट्रांसफर हो रहा है, अब इसमें किस किस का वेट आएगा? दिस पर्टिकुलर सॉइल, इस पर्टिकुलर सॉइल का वेट हमने ले लिया गामा डी इंटू 2.5. ये पर्टिकुलर सॉइल की बात करें विच इज कैपिलरी सैचुरेटेड, अब इसमें वाटर का वेट भी है और सॉलिड्स का वेट भी है, तो आपके पास गामा सैचुरेटेड आएगा. ये सबमर्ज्ड कंडीशन में नहीं है, क्योंकि यहां पर आपके पास बायंसी फोर्स नहीं लग रहा है, राइट? अगर इस पर्टिकुलर जोन की बात करें तो यहां पर आपके पास सॉइल सबमर्ज्ड कंडीशन में, क्योंकि वाटर टेबल के नीचे, तो इसकी वजह से जो स्ट्रेस की वैल्यू आएगी दैट विल बी गामा सबमर्ज्ड इनटू 4. तो ये टोटल इफेक्टिव स्ट्रेस हो गया इस पर्टिकुलर लेवल पे, राइट? Okay, tell me what is the value of gamma D? I'll just check it with my calculations also. Gamma D, are you getting it as 17.22? I'm giving you the values. You just let me know if it is correct or not. Gamma D, I'm getting it as 17.22 kilonewton per meter cube. Gamma saturated I am getting it as gamma saturated I am getting it as 20.64 kilonewton per meter cube. E value which I got it as 0.54. E value I got as 0.54. Just let me know if these values are correct. Yes, 2.79. Yes, and gamma submerged will be 10.9. Gamma submerged is your 10.9, right? So now it is easy. Effective stress will be what? It will be 17.22 into 1.5 plus 20.64 into 2.5 plus 10.9 into 4. How much value you are getting? Option D. Can you give me just value? What was option D? 117.3. Okay, right. It is 117.3 kilonewton per meter square. So every time it is not necessary to calculate the total stress first or pore water pressure then, and then you'll subtract those values, right? So try to do the practice that directly you will be able to find out the effective stress. Just try to understand that, okay, the which material weight you have to consider to calculate the effective stress, when to consider the gamma saturated value, when to consider your submerged value. Is that clear? Now, a very good question. This particular question, okay, this is again your homework for you, right? It is directly based on your calculation of permeability by your constant head permeability test, right? Everything value is given to you. You need to use that particular formula. K is equal to love upon hat. Love upon hat, right? Everything is given to you. Length of sample is given to you, 20 centimeter high. Length of sample is given. Diameter is given. It means area is known to me, you pi by 4 d square. This is your length. This is your area, right? Constant head, that is your 1.5. Head loss is given to you. Volume is given to you, and time is given to you. Everything is given to you. Just need to put the values in such a unit that you will get the answer in centimeter per second, right? So this type of question, it can be asked from your constant head permeability test. Clear? Just remember the formula. All the data are given. Length is given. Area you can calculate from the diameter, right? Volume is given to you. This particular time is given to you. Under this particular head, it means this will be the head loss, 1.5 meter. It is also known to you. So it is an easy question. Do this particular question and give me the answer in the comment box just by mentioning the question number and your correct options, right? So that I'll be able to reply to you if that particular answer is correct or not. Clear? I'm more focused about the questions which will be tricky and which are having a good chance that if you'll get these questions in your exam, you should be able to approach this type of questions. Now, this is also a very good question. Try to read the question and let me know if you will be able to find out or not. A very good question. Definitely from this particular concept, you will get one question in this year, right? It is definite that this particular type of concept you are going to get in this particular GATE 2023. So read the question and try to find out the answer. By then, if you have not liked the session by now, if you are enjoying this particular session, like this particular session, also you can share this particular session to your friends so that after the completion of this live video, they will be able to see, right? As we have done some of the beautiful questions for your exam. Clear? So if you have not liked the session by now, just like the session. Clear? I'm just seeing if like has increased or not, right? Okay, I'll just be side so that it will be clear for you to see the particular question. Just go through the question. I'll give you a minute just to understand that what this question says. Also, if you can let me know the concept of this particular question in the chat box. If you are able to crack what concept will be used here, just let me know in the comment box. I have already discussed this concept also, right? It is just now the implementation of that particular concept. Clear? Those are the classroom students. They will be definitely aware of this particular type of questions and the concept. Just try to solve. Okay, I'll just read the question for you and I'll try to simplify this for you. It is saying that a large sized excavation is made in stiff clay whose saturated unit weight is 17.27 kilonewton per meter cube, right? So it means there is a clay layer, its height is not given, right? So its unit weight is given as 17.27. When the depth of excavation reaches to 7.5 meter, the cracks appear and water begin to flow upward to bring up the sand to the surface. It means there will be one clay layer. This is your clay. This is your clay, and below this clay there is a sand layer. Clear? Again, below this sand layer there can be any impermeable layer, or you can just take this sand layer as your confined aquifer, right? As you know, in the confined aquifer there will be this water under the pressure, right? So there is a water under pressure, and this particular water, if it is under pressure, it will try to come up, right? Now this particular water, it wants to come up, so it is applying a pressure value, that is pore pressure at this particular point. What will be that pore pressure? It will be is equal to gamma W multiplied by whatever is the head at this particular point. Gamma W multiplied by whatever is the head at this particular point, right? But this weight of soil, it is restricting the water to come up. This weight of soil, it is restricting this water to come up, right? But what happens when you have started excavating this soil? When you have started excavating this particular soil, right? So what has happened? That this particular, when you have excavated this particular soil, so at this particular point, at what depth? When the depth of excavation reaches to 7.5 meter, when the depth of excavation reaches to 7.5 meter, cracks appear and water begin to flow upward, right? So at this particular point, what happens? At this particular point, your quicksand condition occur. We have seen one more condition for quicksand condition, that sigma is equal to U. Initially its weight was sigma, the total stress, and its weight, its particular pressure, it was U. So at which point they will be equal, this water, it will try to come up, right? So at this 7.5 meter depth, now your total stress, it is just less than your pore water pressure value. When the total stress, it will be less than pore water pressure value, effective stress will be negative, right? Or at this particular point, if they are just equal, if I consider the limiting condition, the effective stress will be 0. Effective stress 0 means it will be your upward seepage flow. Effective stress becomes 0 in this particular sand. So can I say this is your quicksand condition? So at 7.5 meter there is a quicksand condition. Clear? Now the pressure over this particular soil, it will be what? It will be whatever is the gamma of this particular soil, that is gamma saturated into this height. If I take this height as Z into Z, so this is the pressure acting downward, this is the pressure acting upward. When just these pressure become equal, when these pressure just become equal, this water, it will now come up, right? So up to this particular point we have understand the question. After that, the subsequent boring indicate that the clay is underlain by sand at a depth of 11 meter. When you have done the boring, it is known to you that the clay thickness, it is 11 meter. The clay thickness, it is 11 meter, right? Below the original ground level. This is your original ground level. So below this particular sand layer, it is at 11 meter, right? Now what it is asked, what is the depth of water table outside the excavation below the original ground level? Now once this particular crack has appeared, once this pressure value become greater than this particular value, so now the water table or water will come up. So let's suppose the water is up to this particular level now, right? So this water level will be what? This water level will be H only, as under this particular pressure this water was there. Clear? So at limiting condition, can I say that sigma will be is equal to U? Now at this point, just apply this limiting condition. I can say that my sigma is equal to U value. What is this sigma? This sigma will be your gamma of this particular soil, that is given to you 17.27 into this height Z. This total height is 11, this height is 7.5, right? So it will be 11 minus 7.5 into gamma saturated. and it will be is equal to gamma W into H value. So what will be H? H is going to be 11 minus 7.5. It will be a 3.5 into, what is gamma saturated? It is 17.27. It is 17.27 divided by gamma W, that is 9.81. Can you give me the value? Gamma W, it is not asked to use any particular value, right? Okay. So we have to take it as 9.81 only. Can you give me the height? What will be the height of water? Can you give me the height of water? 6.16. 6.16 meter. Clear? So now just read the question and can you tell me which option will be correct? Just read the question and can you tell me which option will be correct? Just read the question and try to give me the correct option. A, B, C, D. A, B, C, D. Just read the question and give me the correct answer. How many of you are saying it as A? How many are with option A? Aman is with option B. Now try to see. Student make a mistake after this calculation also. Every time try to read the question carefully. It is asking that what is the depth? What is the depth to the water table outside the excavation below original ground level? Below original ground level. This is the water table from this particular level. This is the height of water from this particular level. You need to find out from the original ground level. So this is your original ground level, right? This is your original ground level. It means this height from the original ground level, it will be what? If I just say that particular value is HW, so it will be what? It will be 11. Total height was 11. 11 minus 6.16. 11 minus 6.16. So you will get it as 4.84 meter. So you will get it as 4.84 meter. This is the most type of mistakes students are doing from the previous years also, right? If we see the test series of students, if we see the previous year analysis of the students, right? So this type of mistakes students generally do. It is not like that you don't know the concept for this particular question, but just because you have not read that what is it is asked in the question, you will be able to lose your 2 marks. Clear? So try to focus that what it is asked actually in the question and accordingly you have to answer. I hope this particular concept is also clear. Just let me know if it is clear or not. Just let me know if it is clear or not. Okay. Thank you, Aman. Now, one more question for your homework based on the same concept. This is particularly also for your homework, right? It is also based on that same concept, as the most of the chances that you are going to get a particular question from this concept. So I have added one more question based on the same concept of quicksand condition. You should also solve this particular question, mention the question number and mention the answer in the comment box, right? So this is the particular session for today, right? In next class, we will try to see the flow net concept. We will try to see what is consolidation, what is shear strength of soil. Next class will be more quick, right? Today, as we have just covered some basics also, next part it will be more about the implementation part. So, it will be more focused about the questions, right? So, tomorrow also, just what you want to say, Aman? Okay, previous questions also you want to take the screenshot? Okay, I'll just show those questions also, right? This is one homework for you, right? You can just take the screenshot for this particular question first. Another homework for you is, one more homework question is there. right? So just this is also your homework question. Take a screenshot. This is also one of your homework question. Right? And there is one more question from your calculation of permeability, right? There is one more question about the calculation of permeability. So try to be present. In the next class also, we are going to do some of the most important questions, which will be definitely you will get the same question from the same concept in your exam also, right? So you should not miss those questions also. One is the question, okay, this is also your homework, right? You can take the screenshot of this. So these are the 3 questions. Just give me the answer in the comment box once this particular video will be over, right? I'll try to reply those answers if you got the correct answer or not. Okay. Now, if you want to enroll in our courses, so I'll just give you an insight that the IMS GATE Academy is offering the different type of programs, right? Just to know about the program details, you can visit the IMS India or IMS GATE Academy particular channel, right? You can go to the IMS India website. In that IMS India website, you will find out the GATE ME particular portal. In that GATE ME, you will find out the courses for different branches, right? And these are the courses currently we are offering. We are offering the classroom program. This is particularly the complete offline program, right? Hybrid classroom program. In this particular program, we are covering 2/3 of the syllabus by the offline mode and 1/3 of the syllabus by online mode, right? You will get around more than 750 hours of teaching in all the courses. This is your exclusively live program. If you are not near to our any particular center, you can go for the live online programs also. And there is one self-learning program also, in which you will get your recorded videos, right? Also, these are the particular features, right? So you are getting 100% online classes. It is your 750 hours of classes, right? You are also getting the theory book. This is the most important part which you are getting, right? In nowadays, it is not like we will just share the PDF to you. There will be PDFs also of the lectures, but there will be theory book and there will be exercise book. Each book, it will contain 4,000 plus question for each subject. There is a GATE PYQ we are getting. You are also having a doubt solving portal, right? Where you can just click the doubts and you can ask to our expert faculties. There is a My Plan session where you can take this particular session 1-to-1 faculty, or there can be multiple students. They can also meet the faculty and they can decide about their strategy or plan for the particular preparations, right? We are also offering test series in which there are 130 plus of the test. These are the particular details. And after your GATE exam, we are also providing the post-GATE guidance programs. Clear? So these are the particular thing I have just explained you. Yes. So about the IMS, we mainly work on the LPT model. L, that is your learn. We are providing the 750 hours of the teaching, right? So you will be able to learn all the concepts. In the practice session, we are providing the GATE previous year questions. We are providing the exercise books. For the test, you are getting 130 plus of the test, right? So these are the some details of the test. How many tests you are getting for chapter wise, subject wise, advanced level, multiple subject test and full length test. Clear? So we are also having a GATE zero fee program where you can access these particular content, 100 hours of concept videos, 12 chapter test, 6 subject test and 6 past GATE paper. This is completely free. You can just go to IMS India website, right? And you can go for the free program, right? So it is GATE zero fee program. You don't have to pay any particular price for this. You just have to register and you will get this particular content. Clear? This is the particular our doubt portal. Clear? Here you can just paste the doubt. You can also paste the file also, and it will be sent to our expert faculties. This is your one-to-one and one-to-many mentorship session, as I have already explained to you. So this is all about the particular session. By then, try to revise all the concepts at this particular time. You should start revising your concepts. You should start focusing on those particular points which you have already studied, right? So whatever is your strong point, it's now time. You have to be more strong in that particular case, right? It is not the time that you have to start any particular new subject, but whatever you have studied, that particular things, now you have to revise again and again. Clear? In this particular series, I have just explained you that how you can just go through the revision part. In that particular sequence also, you can just remember the formulas, the concept, whatever we have studied in the classrooms, all those things you should revise on a frequent basis. By then, good night, and again we'll meet on the next class. By then, happy learning. Thank you everyone.